Hey, what's up guys? My name is Chris and welcome to this course on the Django Rest Framework. So the Django Rest Framework is a toolkit that sits on the popular Django Web Framework and enables us to really create elegant REST APIs while writing less code. So the way we are going to be learning this, we are going to be learning it by building a medium-sized application. So in this application, we will cover things like how to set up your environment for Django development, how to pretty much work with models and how to work with the database and models. We'll also look at how to create a custom user. So by default, Django ships with an authentication app that gives you a user model that you can use. But oftentimes this is going to be limited because by default, this only allows you to log in a user using their username and password. Now we are going to be tweaking that and customizing it to allow us to log in users via email. And also we'll be looking at how you can extend it if you wanted to add more details to this user to fit any requirements you might have. So we'll see how to register users. Then we will see how to use JWT authentication. Now, whenever you're writing web APIs, oftentimes they are going to be consumed by different types of clients. Now, JSON Web Tokens provides us a way to have stateless authentication, which means that on the server, we only have to worry about issuing tokens to clients and only verifying who those tokens were authored to. So we don't have to maintain like a separate database table for the tokens and their users, those kinds of things. So it's really great. We're going to be seeing how to set it up with the Django Rest Framework so it works across all our endpoints. So also we see how to log in users, we author them tokens, we give them access tokens so they can access protected endpoints. We'll see how to send verification emails. We'll see how to do unit testing for all the code we write. So basically, whenever you write a modern application or even an application you're taking seriously in any way, you want to make sure that you're writing tests for it, because if you don't, it's going to make it hard for you to refactor it or even add things in the future. So unit testing is pretty much a tool you really would need to master if you want to build any successful project. We will see how to use view sets and URLs to see how we can provide like endpoints to the users. So these are the different ways that the Django Rest Framework provides, so we can expose the resources on our server and enable different clients to consume them. Then we are going to first write most of the things using view sets and URLs. Then we'll refactor them to use generic API views, which are classes that pretty much do most of the heavy lifting for you. Then we'll see how to configure our API to support CORS. So CORS is cross-origin resource sharing, and this pretty much allows you to specify which clients should connect to your API, because if you think of it, anyone can pretty much make a request to your API. Depending on the things you want to be accessed, you also want to set up a policy to define what client applications should access that API. So we'll be seeing how to set that one up. Then we are also going to see how to set up the Django templates and the static files handling. So when we write our API, we are going to document it. Now, when we document it, we need to provide an interface, basically that maybe front-end developers can use to see what the API does, what payload they should be sending to a server, what they should expect. So we're going to be doing that using Swagger. Now, when we do it using Swagger, we are going to need to add another protection to the documentation, because our documentation won't really be public. We would want to at least limit that to like developers to be able to access that documentation. So also, we'll see how to report test coverage. We'll set up GitHub and Travis CI. So these are tools that enable us to catch bugs before we add new code to our existing code. So it's really important we understand them. We understand the importance of why we should have a CI build before we add changes to our main code base. So we're also going to be covering that using Travis CI, which is one of the tools out there. Then we can also enforce things like test coverage. So we make sure that all code we are pushing is tested. Then finally, we are going to be deploying the application. So for the things you need to know, you only need to know like basic Python concepts, things like lists, functions, how to loop through stuff. So it can also be good if you have a background in object-oriented programming, because most of the things that we are going to be doing are going to be Python classes, and we are going to be inheriting things. We're going to be creating abstract classes. So if you have a basic understanding of those, then you're going to do just fine. So if you enjoy this kinds of content, please be sure to subscribe to the channel, like or share the video. Anything you do will really be appreciated because it helps out a lot. Also, you can connect with me on Twitter, GitHub, Facebook, or Instagram, or LinkedIn at ChristTruly, or you can send me an email at christruly@gmail.com if you have any specific questions. So this is the API documentation. This will build it using Swagger. So we can expose all the resources we have and the way these resources should be consumed. So you can see here, we'll set up pagination for to-dos. We will have an authentication system. We'll be sending verification emails when a user signs up. We will be verifying their accounts. If the verification tokens expire, they can resend them. So we'll be providing all those endpoints on there. So we'll set up our application to use the JWT authentication scheme. So all the requests have to be made with an authorization header that has the JWT in there. So really important stuff. So I'll show you how to export this Swagger documentation into Postman, because I understand most of you guys are going to be using Postman. So if you come over here, you can see that I have that very documentation in Postman. So tools like Swagger, Postman, they all pretty much implement the Open API spec, and we can quickly export the Swagger documentation to a Postman documentation. So you have more options of choosing how to basically access the API. So here, when you export the documentation, you can also get a correction of it, so you can quickly test out stuff. So over here, you can see things to expect. You can see the endpoints to hit. So we're going to be seeing how to do these things. So for now, that's going to do it for the introductory video. So in the next section, we are going to start building our application, setting up the virtual environment. And yeah, so if you're excited about the videos, please be sure to subscribe, because I'm going to be making a lot of these kinds of videos in the future. And yeah, I'll talk to you in the next section. Hey guys, welcome back. Now we are going to go ahead and set up our project. So you want to make sure you have Python installed on your system. So if you don't have Python, come over here, download any version of Python for your system. So over here, this is where you can find some guides and some tutorials about the Django Rest Framework. I want to recognize that they have a pretty good documentation for about everything that they offer. So after we go through the project, I recommend you come over here and take a look at some of these things. Obviously, we're not going to be covering all of them, but if you go through our project and then you come over here, you see that things will make sense faster. Okay, so imagining you have Python installed, I'm going to come over here in my VS Code. So over here, I'm going to be working on a Mac. So on Mac or Linux, you will most likely have two versions of Python. So if I came here and ran Python 3 -- version, you can set I have Python 3.8.5. So you want to make sure you have any version of Python 3.6 and up. So if you're on Windows, you want to run Python -- version, and then you should have Python version. So me, I have to put a 3 because I know I have more than one, but you should be able to see your Python version even on Windows. So now that we have the Python discussion out of the way, we need to create the virtual environment for our project. So right now, I'm in my desktop. So over here, we are going to create a virtual environment using the tool called virtualenv. So virtualenv doesn't automatically come with Python, so you're going to need to install it. Now, when you install Python, you get pip. So you can now use pip to install the virtualenv by doing pip install virtualenv. Now, since I have two versions of Python, I need to specify that I need to use pip3. So make sure you run that. So you should be able to get the virtualenv installed. Me, I already have it installed. So now that we have it, we can use it to create a virtual environment. So to create a virtual environment, you're going to first create the folder that's going to contain our project. So here we can now say mkdir. I'm going to call this one drf to do list app. Okay. Then we're going to seed into drf to do list app. So over here, we can say virtualenv and then the name of the virtual environment. So we're going to call ours venv. So I'm going to type venv there. And then when we run it and do an ls, it's going to create the venv folder. Now, whenever we create a virtual environment, we need to activate it. So if you're on Mac or Linux, you want to do source venv bin activate like this. So when we run that, you can see that now it's activated. So if you're on Windows, I recommend you use the git bash command line here, so that you can get the bash environment. So if you don't have git bash, please install git. It will come with git bash. And over here, you can choose a default shell. So you can set it to the git bash one that when you install git, you should be able to get. So on Windows, if you have git bash, make sure it is the one selected here. Then you can run source Then it's gonna be something like venv scripts, then something like this, then activate. I believe like this. Then it should be able to source it in. If it doesn't, then be sure to look up online how to create a virtual environment. I have a video about it. I'm actually gonna link it in the description. So if you're on Windows, you don't get any trouble. So now that we have a virtual environment, we have an isolated version of pip and Python. So here, if I did Python like this, --version, remember now I'm not putting Python 3 here, but if I run this, you can see that it's using Python 3.8. So if I did which pip, so if I did which Python, you can see that it's using the Python in our virtual environment. Okay, so that means that now we can pretty much isolate all our project dependencies into this virtual environment. Similarly, we have pip and it is installed here. Now we can use pip to install Django. So here we can do pip install Django like this. I'm also going to install the Django Rest Framework. Then you should see that you can install it by doing Django Rest Framework like this. So now we can also add, it's gonna be Django, then the Django Rest Framework. So install those. Okay, so that's gonna go ahead and install the Django REST framework and also Django. So right now we have Django 3.1 installed. Now we can use Django to create the Django project. So when we install Django, we get access to the Django admin. So we can use Django. So here we can say Django admin. Then we want to say start project. So then we can give our project name. We're gonna call this one to-do list API like this. Then we want it to get created in the current folder. So here we can put a dot at the end and run that. So when we run that and do an ls, you can see that now we have these other folders that are provided to us. So you see we have access to the manage.py. So here we can now run our project by using Python. We can say Python manage.py run server and run that. So when we run that, it starts up the local development server. We can click over here and we have the Django project here. Okay, so you will see that here in the REST framework, whenever we install the Django REST framework, we want to quickly add it in the installed app section. So we are going to open this project in VS Code. Okay, so over here, I'm going to stop the server and do code dot, or if code dot doesn't work for you, you can just go to VS Code, then you say open folder, and then you should have your project open up. So now we have our project here. So we can go to our to-do list project, then in settings.py, then we want to go to the installed app section and add the REST framework. I'm going to come over here and I create the apps we are going to be working with. If you're not familiar with what apps are, they are basically a way we can group related functionalities together. And we'll do this because apps provide a very good way to reuse code. So what do I mean by this? Let's say you have an app for authentication here. You will know that most of the applications you will build will use the same kind of authentication. So either can be email password, the social authentication. So if we had an app here that did all those things very well, the idea of the apps is we should be able to pick it there and plug into any other Django project and it should work just fine. So here I'm going to create the two apps. So I'm going to do Python manage.py start app. So the first app is going to be called to-dos because you're going to be managing to-do resources, but this can be anything really. So let's run to-dos. Also, let's also create an app for authentication like this. You can think of it as a fully featured module. So here in authentication, we can have everything to do with authentication. So in to-dos, we can have everything to do with managing to-dos. So like I said, we should be able to plug this one from this project to another project and things should work really well. So now that we have all this, I'm going to initialize a Git project so that we can now integrate with Git. And like I said, we need to be doing things like integrating the CI because these are the practices that you're going to need in order to write a successful project. I'm going to go here in the browser and go to .git ignore. So this site allows us to quickly create .git ignore files for the common languages and frameworks. So over here, I'm going to type in Django and then I'm going to click create. And then I should get a sample.git ignore file. So I'm going to come over here and initialize a Git project by doing git init. So that's going to create a Git project. Now we need to create a git ignore file. So we can do touch.git ignore. If it doesn't work, if touch doesn't work for you, you can create it through the finder. Like here you say new. But if you're using Git bash on Windows, you should also be fine. So let's create that. So when we do .git ignore, we can come over here and paste all these git ignore files. So I believe our environment is being escaped. You can see that now it's highlighted. It's highlighted gray, meaning it's being escaped. Okay, so that's gonna do it for our initial setup. So in the next one, we're gonna be looking at the user model and also how to make a custom one for our application. So thanks guys for watching. Don't forget to subscribe to the channel. I'll talk to you in the next section. So in this one, we're going to be setting up a tracking model for all our models. So a little bit of background. Every time you create a Django model, you're going to need a few things. So those are going to be when objects of that model are created, when they are updated, how they are retrieved. So most of those things are going to be common in your application. Now, Django doesn't provide fields like created at, updated at on each model you create. So we're going to be setting up a helper to make sure that every time we create a model, we can quickly add those details at once. So I'm going to go in the root of the project and I'm going to have a folder called helpers. So over here, I'm going to say helpers. Now I'm going to have a danda init file inside it. So danda init. Okay, so also here, I'm going to create a new file called models.py. So in here, I'm going to set up a model that we'll reuse. So I'm going to say class tracking model. So it's going to inherit from models.model. Now we need to import models. So from Django db import models. Okay, like that. So now we can set up our created at and updated at columns. So you can say created at. So created at, it is going to be a datetime field. So every time an object is created, we want to set the created at date to the current date. So here you can say auto now add. We set that one to true. We also want to create the updated at. So for the updated at here, we can say auto now true. So that's going to indicate that every time an object is updated, we should be able to insert the current time when it was updated in the updated at field, or technically called the column. So we're also going to set up a way that our objects are going to be ordered. So most of the times you want to be ordering objects by like the create date in descending order. So here we are going to set up a class meta. So in the class meta, we can set up ordering. Then we want to set it to created at. So I'm going to bring this one here. So if we want to sort objects in ascending order, we'll do it like this. But if we want descending order, then we can put a minus behind. So that's how you do it. Another thing I want to do is I want to label this model as abstract, meaning we shouldn't be using this model to create new instances, because this model is really generic and it doesn't really make sense to create objects of the tracking model really. So here we can say abstract equals true. Okay, so now that we have this one set up, then now we can go to our models for the authentication, since that's where we want to start by creating a custom model. So over here, I'm going to create a class. I'm going to call it user. Then we are going to inherit from the tracking model, so we can get those two fields also. So in here, I'm going to put a pass for now, then we'll come back to it. So let's import the tracking model. So from helpers, models, import the tracking model. Okay, so also as we are here, I want to add the apps we created in the settings.py installed app section, because that is required if we want to like work with the database. It tells Django where to look when we run specific commands. So I'm going to go to our main project folder. So that's to-do list API, then settings py. Then over here, now we can add our authentication and also the to-dos. Okay, so now that we have this one set up, in the next section, we're going to be setting up our custom user model. Hey guys, welcome back. So in this one, we're going to be setting up our custom user model. Our intentions for this model is to be able to allow a user to have new properties. So we want to be able to quickly say for this user is the email verified. So we also want to be able to do things like for this user, generate an access token on the fly for them. Yeah, so those kinds of things. Also, we want to be able to change the way objects are created. So by default, the email is always not required whenever we are creating a user. So we want to enforce it. We want to make sure it is required because now our users are going to be logging in using that. Okay, so let's go ahead and do that. Now to do that, you're going to be pretty much inheriting most of the things that Django has. One of them is going to be the abstract base user. And also we're going to need the permissions mixins. So let's go ahead and import these two. So we can import these from Django, contrib auth models. Then we need permission mixin. So it's going to be permission mixing. Then we also need the abstract base user. So abstract base user. So we need to make sure we are using. Okay, so now that we import this, you're going to automatically see that we have errors down here in the log. That's because right now Django is confused about how to authenticate users. So it's already seeing the initial setup that it already has, and now it is seeing us having another user model that pretty much does the same thing. So to take away this error, what we want to do is we want to go to our main settings.py file. So anywhere in this file, then you want to write auth underscore user model. So here you can set the path to the model class. So it's going to be authentication app. No, you want to do dot the name of the class, which is user. So now if I save this, you see that now the error changes and now it is asking us for the required fields and the username fields. But don't worry, we'll get there. So over here, I want to show you what's in the permissions mixing. So when we hover above the permissions mixing, you can see that this adds all the fields that are necessary to support groups and permission models. So if I click over here and come to basically the Django one, you can see that it has things like a super user, things like groups, permissions, and all that other stuff. So you see it has all these methods that basically do what we saw. So also you notice that here we have something called an abstract user. So this is the class that Django uses by default. Now this pretty much inherits everything we were inheriting now, and this is the one that has all the fields. And down here you should see that it specifies the username field to be username and also the required fields. So we basically want to now override what this class is doing. So I'm going to copy everything in here. I'm going to copy everything. I'm not going to copy these other details because most likely we might not need them. I'm going to copy up to the required field section. Then I'm going to come to our model class. So over here, I'm going to paste them in. Then you can see that to validate the username, there is a username validator. So we are also going to import that one in. So I'm going to come over. So I'm going to come on top here and also bring in the input for the username validator. Then let me actually minimize this here so you can see properly. So here we have the username, we have the first name, last name. We might not need these for now, but if you need, you can keep them. I'm going to remove them. Then we have the email. You can see that the email can be empty by default. So we don't want this really. So here we can set this one to false. Also, we want it to be unique. So we can pass unique equals true. All right. Let's save that. Then here is staff fine is active. Down here, you can see that we need to specify a manager class. Now, a manager class is pretty much a class that specifies how objects are created or retrieved. So every time you want to change how objects are created, you want to define a custom manager and change how methods should behave. So this can also be important if you want to implement things like soft delete. So this is something that's common. Like every time you want to delete, let's say, an object, you want to mark it as deleted and not delete it. And also, let's say you want to retrieve all the objects. You don't want to retrieve the objects that were marked as deleted. If you're going to need to implement those kinds of things, you're going to define your manager and also change how things are retrieved or created. So in our case, we need to alter the way things are created in a way that whenever we create a user, we want to specify that they will be using the email as their login or as their username, which is like the default. But let's first change here the username field to be email and not username. So for the required fields, we also want our users to have the usernames. So we also want to make it required. So for the manager, we are going to be inheriting from the user manager that already exists, but we're going to be changing a few things. So I'm going to rename this one to, I want to call it my user manager. So over here, we can create a class. So this one is going to be called my user manager. Now it's going to inherit from user manager. In here, I'm going to do a pass. Then let's import the user manager. So here, if I did the find and went to the Django models, so here let's search for user manager. So you can see that there is a user manager that already exists. Now it has the create user and then the create super user. It also has this with PAM that basically ensures that the permissions are good of the user object. Now we don't want to touch the with PAM. So what we want to do is override the create user and also the create super user so we can enforce the email. So I'm going to come over here and copy all this stuff. Actually, we don't need this one will be inherited. So I'm going to copy this create user and also create super user up to here. Make sure we are good. So over here, now we can bring them in. So let's make sure our indentation is good. So for the create user, we want to be getting the username, then the email, then the password. Now we also want to add a check to make sure the email is always set. So by the way, every time we are creating a user from the command line or the admin section, we also want these things to be enforced. So we need to really add them on here. So now let's check for the email, make sure it's always provided. Okay, so if it's not there, we should give an error. So we have the email. So we have the email, then we have the create user there. That's fine. So also for the create super user, we want to make sure the email is never none. So we're even going to remove this default param to be none. Make sure it's always required. Okay, so now that we have the create user, create super user, I believe that will do. What we want is to make sure that our import is correct. So instead of us inheriting base user manager, we can inherit user manager here. Make sure that is the one over here. So now in our class, we can now add our properties. So we are going to want email verified like this. So this is going to be a Boolean field. So we can have something like this. So I'm going to copy this and also have it here. It's going to be a Boolean field. This should be email verified. So the default is going to be false because we want to only change it when they actually click a link we send them. Then we can change the helper text. So designates whether the user email, this user's email is verified, should be treated as verified. Okay, let's remove this. So let's remove this. Okay, so now that we have that, we also want to set up a token. Now the token, we don't want it to be saved in the database. So over here, I'm going to set up a function called token. So dev token. So this is going to be, of course, it's in a class, we need to pass self. So here we can have a way that we can generate a token for the user every time we say user.token. I'm going to mark this function as a property. Say that token can be a property of the user, and we can be doing things like user.token without having to instantiate a class. So here I'm going to be returning empty for now, but we'll come back to it when we set up our JWT authentication, so we can be able to generate our tokens. So I'm going to bring up the terminal here. So it looks like we have an indentation error. So over here we have, this should be up to here. Let's save it. So we need to import this underscore from translation. By the way, the underscore is used to lazily translate these keys here if we are creating a multi-language app. Import get text lazy like this as underscore. All right, so we need to import time zone also. So from Django.utils, import time zone. Okay, so when we have this, you see that now down here our things are failing. That's because we need to run our migration. So I'm going to stop the server, and then I'm going to run the Python manage.py, make migrations like this. So now you can see it creates our migration. So if you go to our migration file, you should be able to see that now it even has things that we didn't specify. Also, you can see it has things from our tracking model. So it has the permissions. They are also still set up, and it's using our new manager. Yeah, which is nice, which is what we want. So over here, we can go ahead and migrate it. So now we can do migrate like this and run it. And now you can see that things are set up properly. Our server should be able to still run. So Python manage.py, run server. And you can see that the server is on and things are still good. So that's gonna do it for our custom model. If you guys had other things you needed to add, you could add them here. If you wanted to customize the authentication, creating accounts, you would change the way users are created in this manager we just created over here. Now that we have set up our custom user model, that means that we have introduced new code to the code base. So every time we introduce new code to the code base, what we are doing is we need to maintain that code. And to maintain that code, we really need to have specific ways in place to make sure that code we have written is working properly and it can be maintained in the long run. So basically, maintaining means it can be changed with flexibility in the future. It can be added to, it can be removed, things can be removed without breaking the core functionality that code should be doing. So what we're going to do now is we're going to add unit tests to verify that what we wrote was working, and also to make sure that it can be safely changed in the future without breaking what we have. Now, in the normal scenario, the way we would have done this is we should have written the test cases for what we did first. So we should have written the tests before we did the custom user model. But I understand that most of us might be starting out, and that kind of terminology is what is called test-driven development, but it can be confusing at times. So either way, we are going to be adding tests for it, and if there are any defects, we should be able to spot them as we write those tests. So I'm going to stop the server here. So whenever you run a Django project, you have access to the test command. So I'm going to do python manage.py test like this. And then you can see that there are no tests at the moment. Also, I'm going to be installing a module that will help us to know which lines of code we have not tested, and that's called coverage. So here I'm going to do a pip install coverage and run it. So now that we have coverage installed, then we can use coverage to run the tests and also see the test report. So you can do coverage run manage.py test. Then we want to do and coverage report after test. Also, we want it to generate an HTML folder that can contain a website which we can navigate and see our tests very well. So here you can do coverage HTML like this. So then we run. So that's going to run the tests. Down here you can see that it finished okay. So you will wait for it. So on here you can see that it has tested everything, and we have the coverage. So right now it's saying for 34%, and that's because it has even tested things in the virtual environment. So we want to really instruct it to not test those things. So what I'm going to do is over here, we're going to create a coverage.rc file. So let me minimize. So I'm going to create a file called coverage.rc. So .coverage rc like this. Okay, so in the coverage rc, then I'm going to bring in this. So basically this omits some files from being discovered by coverage when it's collecting coverage. So we want to only be looking in the authentication and then in the to-dos, because that's the only code we have written. If we had another piece of code, we will put it here. If we added another app, we would also put it here. So also we want to be ignoring this. So the virtual environment, everything that has migrations in them, everything that has tests in them, and all these other things. So now if we run back our coverage command again, you can see that this time it's faster, and we can see that we have 50% of tests. So you see that our model file is not tested at all, it's on 53%. Now we need to raise this one to 100% so we can continue writing code confidently, or at least see how we can test it in a scenario if we have to. So here I'm gonna open these folders. So here I'm gonna open this with live server. Feel free to open it the way you want. So it's gonna open in my browser. So here we can click on the models.py file, and every time you see the red, it means that those files we need to test them. So that means we need to test the user must have a username, if they must have an email. So we need to check if the program raises an error if we try to create a user without a username, those kinds of things. So to start adding tests, I'm gonna go back to our app. So over here, every time we have an app, we have access to the test.py file. Since in an app we have many files, so what I usually do is I usually remove the test.py file, and then I usually create another module in a folder. So here I'm gonna create a tests. Then I'll have it under init, like this .py. By the way, the dunder init, if you're not familiar, it pretty much tells Python to look at this directory as a module, and we can basically import from it. So now in here we can have files that test these ones here. So now that we're testing the models, we can have a test_models. So test_models.py like this. So inside this file, you can set up our test class. It's going to be class test model. So we are going to be inheriting from something called API test case. Yes, so over here we can go to REST framework.test, import API test case. Okay, so this is what gives us all the testing utilities, test our APIs. Okay, so now that we have this, we need to check if we really create a user, like if we can really create a user using our new model. So here I'm going to have a def. Now, when you're writing tests, you want to make sure you start each test function with test underscore. Now we want to check if we create a user. So we can say test creates user, of course text himself since we're in a class. Now, every time we import from API test case, we get access to all the assertion methods. So you can do something like self auth assert equal assert equal. So you can do equal 1 equals 1 minus 0. Something like this, just for test. Okay, so this should be true, meaning this test should pass. So now if we run the tests, we should at least get more than 0 tests to run. So let's run it back with the coverage. So if we run that, you can see that now we have the test being matched. Okay, but this is doing nothing. It won't affect our coverage. So now we need to now do the real thing. So to test this model, we basically want to import this class and test all its methods. Okay, so I'm going to import it over here. We can say from authentication with models import this. Now I'm using an absolute import here, like for the app name, then the app name, and then the other module. So we could do this, but for consistency, let's go ahead and use this, because chances are on your team you're going to be doing it using one, and absolute modules are usually the way to go. Okay, so now that we have this, we can check if we can really create users using this model here. So how do we check that? So to create a user, we call objects create user. So you can say user equals user dot objects, then we call create user. Okay, like this. So now you can see that it takes in the username and then the email. So let's take the username as Christ. Then for the email, let's have christchuri@gmail.com. Then we can pass their password here. So the password is going to be, let me pass password 123 at exclamation mark at. Okay, so when we create this, we expect this one to be a user. So now we can have an assertion here. So we can do something like self assert equal. Then we can check if this user is an instance. So we can check if this user is an instance of the user. So how do we do that? So instead of asserting equal, we can say assert is instance. Okay. So now we can say we want this user object to be an instance of user, like this. So also we can assert that this user has this email set to them by doing assert equal. So we can now say user.email is it should be this. So now we can copy this and make sure that is the one here. Okay. So also whenever we call create user, it is calling this one here in the manager. It is calling this one here. So meaning this should not be created as a super user. So we want to add that check there. So we can also assert. So we can assert false. So we want to say user dot is staff should be false. Okay. All right. So now let's run back our test. So let's run it again. Now you can see that it passes, and now you can see that our coverage has increased and our model is tested to 78%. So if we went back to the browser to see our test coverage, you can see that now create user is working properly and we have tested it properly. So let's test the create super user. Now create super user should be also fine to test, should be just similar to this, but really sharp. So let's say we should be able to create a super user. So to create a super user, we want to call create super user like this. So this is all fine, but we expect that this should be true and not false. So if we run this test, we expect it to fail really. So let's run it. Now you can see that it fails. That's because it's saying that when we create an object using create super user, our code is saying that they are being created as staff users. So this staff is true for them. So what we want is to make sure that this is assert true. All right. And that should pass too. So let's run it. Now you can see that it passes and our coverage is increasing. crazily. So that's all good. So if we come here, now we have some tricky things we need to test down here. So we need to test that every time we try to create a user without the username, a value error is raised. So to test that, we can come over here. It should also be easier to test. Let's first have this. Okay, so here we want to say raises test raises, so raises value error, raises error when no username is supplied. So something like this. So let's have it supplied, because test should also be very descriptive. Make sure it's as descriptive as possible. So here, want to call create user without passing the, let's see in the test, without passing the username and also the email. So here I'm going to supply named parameters here. So I'm going to say username equals that, then email equals that, then the password equals that. So now I'm not going to pass the username. So now for us to assert that this raises a value error, the way we can do it is we don't really have to call this one here directly, but what we want is over here, before we even run this, I'm actually going to copy. So over here, what you can do is we can say we can do self dot assert raises. So when you say assert raises, we now specify what we need to raise or the type of error. So we want want to be raising a value error when we run this. So what you're going to be running will be user objects create user. So want to copy this. Don't copy the parameter section. Then you put a comma, and here you specify the arguments separated by brackets. So here we want to pass username, then the password like this. So we can now pass them here like this. So we are saying we need this to raise a value error. So what we want to raise a value error will be this function whenever it is called with these arguments. Okay, so you can say that it's a different syntax or a different way of writing it. So I'm going to remove this section down here. All right, and now you will see that we are not passing the username argument to this, even though the syntax is quite different this time. So now let's run back our tests. So we can run that. So you can see that it fails. And the reason why it fails is because we are not passing the username at all. Now what we want is to pass the username. So username, want to pass an empty one. So we have the key. So a lot of the times when developers are like working on the front end of this, they're going to be supplying the username, because for them, they will know, okay, we need to supply the username, but they won't. So what we want is to catch when they won't. Okay. So otherwise, it's going to be a developer error really on their side. So here, let's run back the tests. And now you can see that they pass. Okay. So if we wanted to adjust our tests to really meet the other first instance, we would do that. We'd first check if it is there, then we check if it is not empty, those kinds of things. But now it's good. So if you come back, you can see that now that is working. So let's also check for the not email. So it's going to be the same thing. By the way, if you wanted to check for if it was called with this specific error, so that can be useful if you want to prevent people to change your code sometime in the future. Then you can now have self.assert raises message. So when you call raises message, the first thing you want to pass is the type of exception, which is the value error in our case. And then the next thing will be the message you're trying to match. So in this case, a message you want to match is the username must be set. So that means we can pass it here as a string. And also, whenever we are writing this code, I'm actually going to create another test function. So let me copy this. So here we can say raises error message, raises error with message. Okay, let's have with message here. Let's remove this because we already have it. And this is just an example because our test is already catching it. So this test might not be that significant, but I want to show you if you want to test for the message. Now, if you want to test for the message, you're going to need to write your code in a context manager. So the way those work is you now write your expression and then you run the function that should raise that exception. So here to write that, you can do with. So we can do with, then we want to do self.assert raises. You want to do full colon at the end, and then inside, now you can run the expression. So the one we want to run is this. So it's going to be user.objects.create. So I'm going to bring in all these. So let me remove this actually. So now inside here, Then we can pass this. So user.objects.create user. Then we want to pass this. Now I'm going to be using named parameters here, so things make sense. So username should be, let's say it's empty, because that's what we want to check. Then email, then the password. So here we can have password equals that. So now if we save this, we expect this to really raise an exception with this message. Okay, so let's run back our test. And you can see that the test passes, although it doesn't increase the test coverage, but this is how you do it if you want to test the message. Okay, so let's test the super user to make sure that the super user is created, because it looks like, oh, we need to test the mail. So let's have this. So for the email, I'm just going to replace here this to email. Similarly, let's have email here. Then when we are passing, let's pass the username. The username should now not be empty. Then email should be empty, because now we want to match it. All right. Then we can now do the same thing here. So username will be there, but email should be empty. So this should be when no email is applied, her name is applied. So this should fail because it is still checking the username. Also, this should pass because we are not passing the email. At least that's what we expect. So let's run back these tests here. So you can see that most of them pass, but this one fails. So it is saying that the given username must be set is not found. The given name must be set is what the program does. So let's change it. And basically that shows that the application is working. So let's change that and now run back the tests. Now you can see that all the tests pass and our models are on 93%, which is great. So now let's check that when super users are created without the is staff, so whenever extra fields are passed and then we are not sending is staff to be true, then the program should raise an error. So let's test these two lines over there. So the way we can test those is I'm going to have a function called create super user with super user status. So anything from that should fail. So it's going to be create super user with super user status, then let's have self. Okay. So let's make sure that whenever we call create super user and we pass like is staff is not true, then it should raise this error here. So the way we do that is we're going to see how we created, actually we're going to be using this context manager type of thing. So let's go here. Now we can have with assert raises. So we need to be checking for this message to make sure this message is raised. So we can come here and then we say super user must have is staff to true. When we try to say it should be create super user, then let's have the username there. And then for some reason, let's say someone passed his staff to false. So that should fail. Should raise this message here. So let's run it. So we need to indent properly. Oh, there's an issue here. So this should be only one. Yes, let's run back. Now you can see that they pass, and now we are on 96%. Now you can see it's covered. Let's also check for this. It should be really easy. It should be similar to this. Okay, create super user with super user status. So let's change this one to stuff. Is stuff. So also here, let's have super user. That's fine. So let's make sure now this message is being raised. And stuff to true. This should be super user to true. Then here we are going to be passing is super. That should always be true for admin users. Actually, it should be is super user like this. Great super user. So if we run this, it should also pass. Now you can see that we have tested to 98%. And then the code that's not tested is this token field, which we are going to be dealing with later. So that's going to do it for now. I hope this gave you a good introduction to how you can test like custom models. Also, I hope it gave you a good introduction on how to test in general, if you guys didn't have any idea how to. So now that we have finished creating the custom user model, let's go ahead and register a user. So we'll be providing an endpoint where a user can supply their username, email, and password, and then we should be able to create their account. Okay, so to get started, I want to mention that I tried to record this video like 3 times in a row. So something always comes up and somehow I lose the recorded file. So one of the things I changed here is how I named these test functions. So I believe what we had was okay, but I just changed the names to make sure they are aligning with what the test is doing. So don't get confused on that. All right, so you could cross check on that, but let's go on and create our user. Now, what will happen? Let me first get my Postman up. Postman. So what will happen is when a user sends a request, we need to handle it, meaning we need to have a view that handles it. So we're going to go to our views.py. So we are going to be using class-based views here. That's because with class-based views, we can inherit a lot of functionality that already comes in Django, so we don't have to write a lot of code. So here I'm going to set up a class. It's going to be called register API view. So this one is going to be inheriting from a generic API view. So I'm going to come here and import generic API views from REST framework. So I'm going to do from REST framework .generics import generic API view. So then we are going to inherit from it. Okay, so when we inherit from generic API view, we can be able to handle all our HTTP methods that the user makes individually. So we can do like get, we can handle get, so that's self request. Then we can handle post, put, patch, delete, just like this. We want to handle a post request because when a user submits in the form, let's say on the front end, we are going to be sending data to a server. We are going to be posting data to a server. So we're going to handle it as post request. So text in self and request. So when we get this data, what we want is we want to get the data that the user sends, which we can get from request.data like this, and send this data to a serializer. Now, what the serializer is it's pretty much a class that is responsible to turn JSON data that the user sends to our program into Python native objects. Because when a user sends JSON, we need a way to map it to like a model object. Okay, so the class that helps us to connect those two is called a serializer. So similarly, the serializer can help us to get data, let's say like model data, and turn that into JSON and send them to the user. So here I'm going to create a class called I'm going to create a file called serializers.py. Okay. So over here, I'm going to import serializers from REST framework. So from REST framework, import serializers. Then I'm going to set up a class. This class is going to be called register serializer. So this one is going to inherit from serializers.model serializer. And the reason why we are inheriting from model serializer is since we already have models, Django can already predict some of the things that we might want to do. Okay, so we'll see what those things are as we go. So here, let's set up a class. So when we do class meta, we can be able to add some extra information to our serializer. So here we can tell it to use the model for the user. So here you can do model equals the user. So let's import the user. So we're going to do rest from authentication.models import user. Okay, so the model is going to be the user. Then we also want to specify the fields. Okay, so the fields part is very important because the model has actually let me first rename this to serializers. Let's messed it up. Serializers. Okay, so the fields are very important because with the fields we can define which keys and attributes or data we want to be sending to the front end, or we want to make visible to the front end. So if we have data, let's say we have things like first name, last name, when the user last logged in, we might not want to be sending things like when the user last logged into the front end. So, but we know we can want to send the username, the email, okay? The username, the email, and also since we need the user to send us the password, we can also get it. So here we can also have the password. So I'm gonna come over here and also include password. And now when it comes to the password, we want this password to only be write only. So we don't want to be sending the password back to the user on any request or any query. So here what we want is we can send a password. So we can say password equals, then with serializers we can define a serializer field. So we can say serializers dot child field. So we can specify like how long we would want it to be. So we can say okay, max length 128. We can also have like min length. Let's say every password should start from 6 characters. Then we can define that this property or attribute should only be write only. So we don't want to send it at all to the front end. Okay, so now that we have set up our serializer, we can come back to our view and we get the data. So when we get the data from the user, we need to set it from the serializer. So here, when it's a class-based view, you can set up a serializer class. Okay. So serializer class, now we can reference our serializer. So let's import it. So from authentication dot serializers, import register serializer. Okay. So over here, what we can do is we can set up that serializer. We can set up a serializer, then we can now use the register serializer, or we can do self.serializer class like this. Then now we can pass it the data. So you can say data equals request.data. Okay. So now that we have this data, we are passing it to the serializer. Now we can check if this serializer, because the serializer is going to do some validation. So how is it going to do that? It's going to match the data we are sending from the user, and then it's going to match it from the rules we have set here. So if it's a model serializer, actually this should be like this. So if it's a model serializer, it's going to try to match the data we are sending from the user and the rules that these, or the validations that those fields have on the model. Okay. So meaning when we pass the data here, this is capable of doing those validations for us. Okay. So here we can check if serializer, then we can check is valid. So if the data we send to the serializer is valid, then we want to save that user. So here we can do serializer.save. Okay. Now, when we do .save, we need to make sure that our serializer implements the create method. So we're going to go to our serializer here and also implement the create method. So we're going to do def create like this. So create takes in self and also the validated data. So by the time this one is called, the data will have been validated. Okay. So what we want here is to create a user. So we're going to do return user.objects.create user. So then we can pass all our data. So we're gonna do validated data here. Okay, so we are doing this because the user might not only be sending the information we have here, but they can also be sending things, other extra parameters. So we can pass them here because if we go to our model, then the create in our manager, you can see that it can take in these other fields and it's able to save them. Okay. So we also need to make sure we are passing them. So if they send first name and our model has it, then we can save it. Okay, so now that we have this, let's go back to our view. Then we need to, after we save, we need to tell a user that their account was created and they can log in or something like that. So here we can return a response. So to return responses, Django Rest Framework already has some response classes. So let's import some of those. So from REST framework, import, let's get response. Okay. So here we can say return response.response. So this takes in mostly the data and then the status, okay, headers and all these other things. So we only want to send the data. So how do we get the data? So whenever we create an object here by using this create, the serializer is going to look at the fields we have here, and this is what is going to return in the data, the values of what it saved for these fields. Now notice that the password is only write only, so it won't be sent back. So we can expect the email and then the username. So I'm going to come over here and now return serializer dot data like this. Okay. Then the second bit can be the status code. Now Django already has a specific utility that gives us all the status codes. Now here we can say status equals status dot created, because when we create the resource on a server, we need to send back a created response. Now the serializer may not be valid, meaning we might have failed to save the user information. So we need to return a 201 instead, and then the errors that might have happened. So you can return a HTTP 400, actually not a 201, but 400. So 400 means that the request that the user sent had issues. Mostly maybe there were validation problems or anything. So it originated from the user. So that's why we are sending a 400. Now, when we are sending this response, we want to send the errors. Okay, so the serializer also has the property for the errors that happened. And it gets these errors by matching between our validations. So if maybe a password was not equal to 6, it's going to know which error to send. And you can of course customize all that stuff. Also, it's gonna match through this. If this is taken, it's gonna send us those errors. So it's gonna be reading everything for us. Okay, so I believe now we can test out this, but to test it, we need a way to expose this view to the client. Now we do that by creating a URLs and also putting our URLs out there. So I'm gonna come over here and create urls.py. So in URLs, I'm gonna have a URL pattern. So URL patterns, sorry, is an array. So here you can have a path. So when we specify a path, so that's like when a user hits an endpoint called register, then we want to serve a view. So we serve that view. Let's import views up here. So from authentication, import views. So here we can serve the register view, Then we want to call as underscore view, because it's a class-based view, so we need to put as view so Django knows how to handle it. So the name is to uniquely identify this view, so Django can quickly, using this name, reverse to know everything else about the view. So now that we have our URL patterns for the app, we need to make them available in the global URLs. So if we wanted to combine all the URLs in for a whole app, because here we're going to be having things like login, okay, things like login here. If we wanted to combine all the URLs that are defined in these URLs patterns, we can do that by using the include utility. So you can import include there. Then here we can also specify our path. So here we're going to be checking when a user goes to API/auth, okay? So when a user goes to API/auth, then we want to be sending them to the URLs for the authentication. So we can use the app name, which is authentication. So authentication.urls like this and save. So since we are including many URLs, this should be in include. Okay. So now we can do include here. Save that. Let's restart our server over here. Should be URLs, not URL. All right. So restart it. Okay, so we are unable to get model serializers. Let's go to our serializer and serializers and see. So here, so we need to do serializers.model serializer like this. Okay, so we also need to import path in our view and our URLs. So from Django.urls import path. Okay, so now that our server is on, if we click on it, you can see that now it's not rendering our default homepage, but it is showing us the URLs that are available. So you see we have this API/auth. Now to access this, remember a user is going to be making a post request, and the browser can't make a post request. It can only make those post requests using the browser APIs like fetch through the XHR. So what we need to do now is to have a client that can enable us to make post requests or simulate how the post request should be. So I'm going to open up Postman. So I'm going to search for Postman here. I believe I already have it open. So it's here. Now I initially did some testing because I recorded this video like 100 times. So what we want to do is you want to go to your Postman, then you want to say new request, and then you want to put our URL. So remember now we have /API/auth. So we're going to put this, then /register, because that's where our registration view lies. Then you put your user data in a JSON object. You want to make sure that here in the body, let me actually minimize this a bit. You have JSON selected here, okay? And then you can create your JSON object, and then you can send. So I'm going to first try without sending anything. So I'm going to remove all these values over here. All right, let's see. Then try to save this. Okay, so when we send this information, you realize that they tell us that this field might not be blank, and that is being read from how we specified in the models. Okay, so whenever we have something like blank equals false, then it's going to be giving us this error by default. But if we remove the full key, let's say we remove email in our request payload and send this, you see that for email it is required, so it's not seeing it. So these are the things I really love about Django, and can really save you a ton of time, a ton of validation. So let's save a user. So here I'm gonna come and enter an email, a username, and also a password. So for the password, let's say I enter this and try to submit. You said the user is not created. because it actually created a validation rule based on what we specified on the serializer. Okay, so here let's now create a solid password. By the way, you see when we get errors, it's sending us a 400, meaning the error is from the user. But now if we put correct information and try to submit, you'll see that now it creates our user and it gives us a 201. Okay, so yeah, so that I believe that's gonna do it. If we try to send this one again, you see that now it is also checking that the usernames are taken or they already exist just by looking at our models and matching validations. Okay, so that's gonna do it for now. So in the next one, I'm gonna come in and we start to log in a user pretty much. Hey guys, welcome back. So last time we were able to register a user. So we can come here, add some user information, and then we can post and send, and then you can see the user is created and we get a 201. Okay, so now we want to be able to log in this user. So the way we're going to do that is we need to log them in, like authenticate with Django, and also give them an access token. Okay, so they can use that access token after logging in to access other endpoints like creating a to-do item and all that stuff. Okay, so here we have the register API view. Now we need to create the login API view. So I'm going to go here and create a class. So this is going to be login API view. So we also are going to have to inherit from generic API view. And here we need to handle the post request, because when a user sends data to a server, they are making a post request. So here we are going to have to handle a post. So dev post, so self and request. So here we're going to be handling the authentication. Now I'm going to come over here and import some few utilities. So from django.contrib.auth import. So we want authenticate. Okay, so over here, then we are going to try to get their username and password. So actually we are going to need to get their email and password. So yeah, what I'm going to do is I'm going to say email. So email is going to be request. So we can get the user data from request.data. Okay. So we're going to do request.data.get email like this. And then let's also get the password. So we can just do the same thing for the password. Now, when a user doesn't send these keys, get will throw a key error. So for us, what we want to do now is do none here. Let's also do a none here. Okay. So now that we have this, we need to authenticate this user from these credentials. So yeah, we're going to do user. So we're going to do user equals, we're going to use authenticate. So authenticate. So with authenticate, we can pass the request. Also, we can pass the credentials. So right now we are not really authenticating a request at all. So we can pass the username and the email. So for the username, I'm going to do username equals, then the username here is going to be the email, because we are, remember our username field is the email. So that's what we want to pass here. So also we can pass the password. So we're going to do password equals this password. Okay. So you can check if we have the user. So basically if user, then what we want to do is we want to log them in and send them a token. Now, for us to be able to author JWT tokens, let me do a pass here. We're going to need to have to install PyJWT, which is a module that enables us to work with authoring JWT tokens, decoding them, encoding them, all those kind of things. So I'm going to stop the server here and install it. I'm going to do pip install PyJWT. So now that we have PyJWT installed, I can run back my server, and then we can go to our models. So remember, we have a property on the user model. So here we would want to be able to just say, for this user, give us a token. So when we say for this user, give us a token, it should be able to come to our models and run this function here and return us a token. So what we're going to do is we're going to import PyJWT. Actually, import it as JWT like this. Also, I'm going to import settings, because when we are encoding tokens, we are going to need to use a secret key. So here we can import, actually we're going to do from django.conf import settings. So here in this class property, what we can do is we can now create a token here. So we're going to say token. going to be equal to JWT. So with JWT, we can call encode. So when we say encode, we want to encode some information so that we can get a token. Okay. So this special information, or this information which you're seeing as payload here, can be called a payload or claims. So I'm going to put an object here. So what I'm going to do is I'm going to put there a username. We're going to do username. So the username here is going to be self.username. So the username that's currently being used for this class. So also I'm going to put there the email. So you can guess the email. It's gonna also be self. So email, it's gonna be self.email. So also we can put there like the how long we want this token to be valid for. So we can have there exp, which stands for like expiry time. So then I'm going to import date time here so we can construct how long a token should last. So from date time, import date time. Okay. All right. So for the expiration date, we can now do date time. Then we can call UTC now, which will give us the current user's time. So then we want to add there some X amount of time, how long we want our token to be varied. So we're going to be using the time delta helper, and then here we can specify settings or even hours. So I'm going to specify hour for now. So hours, this can be 24. Okay. So normally what you want to do is you want to make sure that your access token is short-lived, and then you want to have a way to create a refresh token which is long-lived. That means that your access token can be live for something like 15 minutes, and then you can always use a refresh token to refresh it. But for now, let's set it to this so we don't have to keep logging in again in our API. Okay, so now that we have this, we actually need to import time delta. I believe time delta is also here. Okay, so let's see. So first we pass the payload, which is what we are passing. Then the second thing we pass is the secret key. So we're going to be using our application secret key to encode this token. So I'm going to do settings.secret key. Then the other thing is going to be the algorithm we want to use to sign this token. Now, the difference between these algorithms here mainly is about speed, like how long it takes to break the encryption. Now, we're going to be using HS256. Okay, so let's make sure we have things set up properly. So settings with secret key. Okay, we need to end this here. Okay, like this, and step this one down. All right, so now this means that we can be able to do token.token. And down here, let's return that token we just created. So that means that if we do token, it's gonna return this token that we get by doing JWT encode. Now we're going to go to the serializers for the registration, and we're also going to set up a serializer for the login. So here we're going to have a class login serializer. So also we can inherit from this, no problem. Let's do that. So in here, we're also going to need to validate the password the way we did. So I'm actually going to copy this section over here because it's going to be similar. Then the password is okay. So this helps us to get some validations up front on the front end. Then we want the email and the password and also the token. So I'm also going to have token here, okay, because the token now is a property that exists on the user. So yeah, so let's do this. We only want the user to be sending the email and then the password. So if we wanted to have, let's say, a read-only field, we would actually specify something like this here. But you can also have a property here called read-only fields. So read-only fields. And then this can also be a list. So we want to have token as read-only because the token is going to be served by application and we don't want to make a user send it to a server. Okay, so when we make that one read-only, it's okay. And things look good to me. So over here in the views, whenever we authenticate a user, we want to send now a response back to the user. So here we can say serializer equals, actually here let's have serializer class. It's going to be login serializer. We need to import it. All right. So serializer equals self serializer class. Then we need to pass the data if we wanted to. So here the data we want to pass is the user because that's the one we want to pass to our serializer, and the serializer can use this user to give us the things we need. Specifically the things like the token and also match the incoming data. So when we do this, now we can return serializer.data So can return response.response. Then this is gonna be serializer.data. Then for the status code, this is gonna be a 200. So you can do status equals status dot 200. Okay. Okay. So otherwise, if we don't have a user, that means the authentication failed. So I'm gonna duplicate this. So when we don't have a user, we're gonna be sending serializer. Actually, we're gonna be sending just a message. So here, I'm gonna have a message. Then I'll just say invalid credentials, try again. Okay. Then the status code, when the authentication failed, we can send a 401. So we can say 401. All right. Not gone, but unauthorized. Okay, so now that we have that, we need to add it to our URLs so the application can pick it up. So we can now come over here and say login. This is gonna be login API view like this. Then here we can give it a name. Okay, put a comma because it's a list. Now, if you come back over here and now try to log in this user, try to log in, you can see that now our user is created. You can see, and we get the token. Okay, so if you wanted to add other fields like the username in the response, you can just come over here and add them in the fields. Let's add a username. All right, and now if we try to submit, actually it doesn't even need to be here. If we try to log in, you can see that now it is sent to us. All right. Okay, good. And then we have our JWT token, and now we can use this to pretty much access the protected endpoints. Okay, so that's gonna do it for this video. By the way, let's try to sign in a user that doesn't exist. Okay, so you see we get 401 unauthorized and we get invalid credentials. Please try again. Hey guys, welcome back. Last time we left off when we could log in a user. So you can register a user and basically come over here and then make a request to the login endpoint and then get our user authenticated. If the user's password is not correct, we get the invalid credential message. But when it's correct, we go ahead and get the JWT token given to the user, and then the user can use this token to access other endpoints. So what we need to do in this one is be able to set up JWT authentication to work with the Django Rest framework. So if you're not familiar with what JWT authentication is, or even token authentication in general, what happened was whenever we logged in this user, we went ahead and created this hash or this JWT token here. And in this token, there are things like the username or the email that we encoded in here. So on the server, when we have this token, we can be able to tell which user it is, and we can track everything they are trying to do. But for it to be able to work, we need to basically write more code and configure it with the Django Rest framework, since it doesn't come with JWT authentication configured. So basically, we want to be able to do request.user in any of our views, and when a user is logged in or when they have the token, be able to get that user. So here I'm going to create a class here. So the endpoint that comes to mind that we can test with is an endpoint that can return for us the current logged in user. So over here, I'm going to call this endpoint, I'm going to call this view auth user API view. Then let's inherit from generic API view, and then let's handle a get. Since for this for this endpoint, a user will be making a get request with a token in the header. So here let's have a def get text in self and request. You know that with Django, to get a logged in user, you can be able to do request.user. Okay. And for this to work, for this not to throw an error when the user is not authenticated, we need to have permissions set up on this view. So over here with generic API views, we can set up permission classes, and this has to be an iterable. It can be a list or a tuple. So over here, make sure you import permissions from REST framework like this, and then we can now use permissions. Then we want the user to be authenticated to access this view. Okay, meaning they should have a token at least. So now that we have the user, we need to basically serialize this data and send it back to the client as JSON. Now we already have the register serializer. So if you take a look at what the register does, it basically, whenever we register a user, let me actually show you something here. So if you go to register, is it register sign up? Yeah, register, I believe. Yeah, so if we register a user, you see we get their username and email, and this is what we want to get when we say get current user data when we have only the token. So we are going to use the same serializer that gives us this data, and that's the register serializer. So over here, I'm going to have serializer equals register serializer. Then we can pass in the user. We need to serialize the user data. Basically, request.user returns for us a user model instance, and that's the one we pass here so that we can get a serialized version. So here we can return the response to the user. So we can return response.response, and then we can send serializer. Actually, I'm just going to have a user's key here. Then we will have serializer.data. Okay, serializer.data, like this. Okay, so now that we have this view, we need to hook it up in our URLs. So I'm going to go to our URLs and also have the one that has a /user. Then it's going to be auth user API view. Let's change the name so it's unique. So basically now we can go in here and make the GET request to our URL. So we can do /user. So when you do this, you see straight off we get authentication credentials were not provided, and that's because we are not providing them. So what we need to go to our login and get that token we get. So let's make the post instead. So when we get the token, we are going to copy it, and then now if we go to our auth, in Postman you have the auth tab, so you can use this. You want to select bearer token. Now what happens when you select bearer token is here, let's say we put the token here, Postman will be making the request, but it's gonna be prefixing this token with a bearer like this, bearer space then this. So this is something you will need to do manually if you're not using something like Postman, but you can see that the scheme is implemented using this convention. So you have the bearer space then the JWT token. So here if we make the GET request with the token, so I'm gonna go to here, then we do the GET to the user. You see that still we are not able to get that user even when we are passing a token and we are sure we just got it from login. And that's because we need to set up JWT authentication for our application. So to be able to set up an authentication scheme, we are going to need to create a class that inherits from base authentication. I'm going to create another module called jwt.py. So over here, I'm going to reach out for some things from REST framework. So I'm going to go REST framework authentication. We're going to import get authorization header. We're also going to import base authentication like this. Okay, so here we can set up our class. So I'm going to call this class JWT authentication. Then we are going to inherit from base authentication. So if you go to base authentication, you will see that we need to implement a method called authenticate, and all this stuff is documented here. So if you go to the documentation, you will see that for you to be able to create a custom class to authenticate, you need to inherit from this class and implement the authenticate method. So our goal in the authenticate method is to be able to return the user and the token once we have them, or to throw an authentication failed exception. So that's what we need to do. So over here, let's go ahead and implement the authenticate. So in JWT, let's have def authenticate. Okay, so in authenticate, what we need first is to get the authorization header. Now here we can do authorization. I'm just going to say auth header. So from REST framework authentication, we have this helper to get the header. So you can say get authorization header, then we pass it the request. Okay, so that's going to give us the headers, but the headers come in a format that we need to first decode and make sure that Python can easily work with the data. So here you can say auth data equals auth header, then we want to call decode, then we can pass in the encoding. So we're going to use UTF-8, and then here we basically have the token string we can work with. So now that we have the auth data as a string, we can go ahead and split it so that we can get the token. So here I'm going to say auth token. So this is going to be auth data, then we can call split on it. So we're going to split by the space. Okay, so here I'm going to do a simple check to make sure that we have the user is sending a token in a correct format. So I'm going to do if the length of the auth token, because when we split, it's going to give us a list with 2 items, bearer and then the token string itself. So here we can check if it's not 2. So if it's not 2, then we can raise an exception. So here I'm going to do raise. Let's import exceptions. So from REST framework, import exceptions. So here you can do raise exceptions. Then we want to call authentication failed and then say something like token not valid. Okay, so if this passes, that's going to mean that we have a valid token we can check. So here I'm going to have a token variable. This is going to be now, this now is going to be the token in the first index, because now we have bearer in the first index, and then we have bearer in the 0th index, and then token in the second one, which is 1 actually. So here you can do auth data, auth token, then 1. Okay, so now that we have the token, remember our method, our authenticate, needs to return the user and then the token, and the user has to be an instance of our Django model. So over here we need to get now the user who has this token. So what we'll do is we're going to first decode it so we can get the username from it, since, as you know, in our models, whenever we assign a token to the user, we encode in there the username and then the email, so we can get this very information to be able to query our model by that user. So over here I'm going to have a payload variable, then it's going to be, let's import JWT because now we need to decode our token. So import JWT. Also we are going to import settings because we need to access our secret key that we used to sign. So from Django conf import settings. Okay, so over here now we can say JWT, we want to call decode. So decode takes in the token string we want to decode. In this case it's token, and then the second one is the secret key we used. So ours is the secret key in settings. So here you can do settings, secret key. Then the second part we need to pass in the algorithms key. So this is going to be either a list or none. So it is required that we pass it in. If we don't pass it in, it's going to fail. So here we pass algorithms. Then let's see the one we used. It must match the one we used when we were creating that token. So we used HS256, and that's the one we want to use. So I'm going to come over here and pass it as a string like this. Should be fine. So now actually here, since we are decoding the tokens, it's likely that when we fail to decode the token, our application is going to throw errors. So what we want to do here is wrap everything in a try except broke. So I'm going to have a try, and then I'm going to just indent everything in here, and then let's have an except. Let's have an except so we can handle our errors properly. So except, first off we want to handle when the token is expired. So here you can do handle JWT.expired signature error. Okay, so here now we can also raise an exception like this when the token has expired. So let's raise it and then say token is expired, login again. Let's also handle when the token is not a good JWT, or if the user really tampered with it and our server doesn't understand it. So that's gonna be a decode error. So you can say token is invalid. Okay, so now that we've handled our cases when we can't really get the token, so over here now that we have the payload, this means that we have decoded our token and we have the user. So now over here now we can get like the username. Let's have it as payload username. Okay, so now we can, since you know for this method we need to return the user instance, we can now query our model for this user. So let's import our model. So from authentication .models, import the user. So import user. Okay, so now over here we can now say user equals user objects dot get user username. So this might also throw an error. So when it throws an error, the error will be handled inside these excepts. So to handle that, we can also except user does not exist. This one as no user. Okay, so here we can also raise an exception. So we can have something like raise exception, no such user. Okay. Okay, so if this goes well, we will have our user, and now we can return this user with the token. So you can say return. We need to return this as a, if you take a look at the documentation, we need to return it like this. So we can return user and also the auth token. Actually, the token itself, the token string, which is token here. Okay. So now, if we go back to our Postman and we try to do the same request, notice that it still fails, and that's because the Django Rest Framework doesn't know that we were creating a class that we think can authenticate for us. So what we need to do is we need to go to our settings.py and also tell the Django Rest Framework to use it for authentication. So we'll go anywhere around here, and then we are going to set up a REST Framework config, and in here we want to set up the default authentication classes and use our own. So if you go down here, we're going to have something like this. I'm going to bring it in. So here we can now put the path to our authentication module. So in our case, it's going to be in authentication, which is the app. And then we want to do .jwt authentication like this. Okay, so now that we have this, then we can go ahead and now test it again. So I'm going to go to still the same request and click send. So notice that we get token not valid. Yeah, so you notice that here we are sending it like this, but we want to, since we are using Postman, it's already adding the bearer. So we want to remove the bearer ourselves and then click send. And now you can see that our application is sending us the user who has this token. So the way that's happening is in our view, we just do request.user, and Django Rest Framework will already have done the authentication using the method we described here. Okay, so that's it. That's how we go about setting up the JWT authentication scheme with Django Rest Framework. Now, I want to mention that there are some libraries that you guys can use to implement most of the use cases for JSON Web Tokens. So the recommended one is Django Rest Framework Simple JWT. I have some tutorial on those. I will basically leave a link for the series where we use this in the description if you guys want to see how we use it. So it can cover a lot of use cases, but I wanted to show you what exactly happened behind the scenes. I believe even with that module itself, they go ahead to implement something like this. But the good thing with it is they already have all the code written. You can just use it. But it's really important to know how things are working under the hood if you want to implement things that are in the similar nature. So yeah, that's gonna do it for this video. I hope it was a little helpful. If it was, please give it a thumbs up. Don't forget to subscribe to the channel, and I'll talk to you soon. And by the way, if a user here enters something that's not correct, see we get token is invalid. Last time we were able to set up our JWT authentication scheme, and now our application is able to recognize the user when we send the token in the authorization. So in this video, what I want us to do is to go ahead and set up a way that the user who logs in can go ahead and create and retrieve some resources on our server. So the resource we're going to be working with, of course, is going to be a to-do model. We've already created our to-dos app. So we want to come in the to-dos app and set up a to-do model, and then we can work with it. So before we get to that, one thing you would have noticed is when we set up the JWT authentication scheme to work across our application. So if we come to our settings, you can see that we set it up to work as the default authentication class, meaning that Django Rest Framework is going to be using this to protect all our views. So there are some views that we may not want Django Rest Framework to first try to authenticate a user before it can give access to the view itself. So for those kinds of classes, what we want is we want to override the setting by setting up the authentication classes list. So here we can have an empty one, and when we set up a property here, this is the setting that Django Rest Framework is going to be using if we set it up on the view level. So if we don't, it's going to fall back to using what we have in the settings, and that might not work for views like login, that we might not need to check the token. So to show you how that one is, if I comment this and I try to log in again here, you said the data token not valid, but we don't want it to check for those things. So we're going to set an empty list of authentication classes. And now if we try it, you can see that it's working. We would have to do this even for the other set of views that we don't want authentication on, that are open to access. So even here, we on register, we can have it. And other cases I can think of are things like resetting a password. So let's continue to creating our to-do model. So the first thing we want to do is have a way to construct how our relation is going to look like. And for people who are not familiar, a relation is basically a database table. So here, what I'm going to do is I'm going to import our tracking model. You guys remember the tracking model, it's in helpers, I believe. So we can do helpers, those models, import tracking model. So this helps us to add the 2 timestamp fields, the updated that and the created that, and it kind of manages things like the ordering for us, so we can reuse this on many models we might have in our application. So here, let's have a class for the to-do. So whenever you're defining a model class, you want to make sure it's a singular version of what it contains. So if it's for to-dos, then call it to-do. If it's for products, call it product, and so forth. So then we are going to be inheriting from our tracking model. So when we inherit from our tracking model, now we can add our own fields. So for our to-do, we want it to have the title. It's going to be a char field. We can specify a max length. We need to import models here. So from django.db, import models. Okay. So we're also going to have a description. So I'm going to say desk. It's going to be a text field. I'm actually going to keep it short. Then the other thing we're going to need is complete. So we're going to have is complete there. It's going to be a boolean field, not a boolean text field. So this one is going to be false by default. So we can set a default. So default is going to be false until the user can manually come in and say, okay, this one is done. Okay, so probably here we want to have a string representation of this class so that it can become readable whenever we are viewing it, like in the admin or in the terminal. So here we can have a def under str, and then for it we can return the title. We can say self dot title. Okay, so it's adding this typing. I'm going to remove the typing for sure, such that we just keep it simple and neater. So here we need to also have another attribute for owner. So it's going to be a foreign key. Now, when you define a foreign key, you want to specify the model that this to do is going to be attached to. Now we're going to use our own user model. So we're going to need to import it from authentication. So from authentication models, import user. Then we can reference it here. Another thing we need to pass here that is mandatory is what should happen when the owner gets deleted. Now, most of the times what you want is to delete even the to-dos that owner had, because no one would care anymore. Or sometimes you might have other use cases, like you want to keep all the records. Maybe you need them for something. But here you specify on delete, and then what we want is we want to cascade, meaning we want to also delete the to-dos that were associated with that owner. Now that we're done here, we're going to go to the views and set up a view that will handle how to create a to-do. Now, Django Rest Framework provides certain views that we can use to handle this, but the one that will handle that use case is the create API view. So we're going to need to first import it from generics, from Rest Framework, generics, import. So it's going to be create API view. And then we can set up our view class. So we can say class create API view. So I'm going to call it create to do API view, and then we'll make it inherit from create API view. Okay. So when we inherit from create API view, Django Rest Framework automatically handles the post. So whenever a user is making a post request to this, it is handled under the scene. So what we want to do is to tell it a few things, and it's going to be able to handle the creation. The first thing it's going to require from us is how to serialize the data that it gets, because if you think of it, whenever we go to like Postman and we make an API call to our server, we are sending JSON, right? But that JSON has to be turned into a model object and saved into our database. So the serializer can be something that sits in the middle of our views and our database, making sure that the data formats can be understood by different clients and our server. So we're going to go here. So I've created the serializers.py file. So over here, what we want is to set up that class that's going to be responsible to serialize our object, our to-do objects. So here, I'm going to import serializers from REST framework. I'm going to do REST framework dot serializers. So we're going to get a model serializer, since for the most part, everything we want this serializer to do will basically be create, read, updates our model. So what we can do is we can inherit from model serializer, and then when we inherit from model serializer, we can come here and set up our serializer class. So we're gonna call it to do serializer. Then let it inherit from model serializer. So here what we want is set up a class meta. So in the class meta, then we can define other information that this serializer should know about. One of them is going to be the model. So we need to set model to our to do, that it knows what things like what fields to check for. Let's now import our model. So from to do's, import to do. This is going to be dot models. Okay, so we set it up here. Then another thing we need to do is set up a list of fields. So those are going to be the fields we want our serializer to be able to serialize back and forth. So I'm going to go to our model and get almost all of them: title, description, and then is complete. So title, description is complete. So for the owner, we are going to be handling the attaching an owner to a to-do within our view. So here, what we want is now to specify the serializer class. So we can do serializer class. Then we can set it to do serializer. So when I do that, it's going to import for me. Make sure you get that import there. If it doesn't come for you, make sure you import it. So another thing we need to set up is, since this is going to be a view that we need the user to first authenticate to be able to access, we are going to now set permission classes on this view. So we're going to do permission classes, and then we are going to need the user to be authenticated. So let's import permissions from REST framework. So dot permissions import, we need is authenticated, and that's the one we want to add here. So it needs to be an iterable, so we'll put an comma at the end, so it's a tuple. Okay, so now that we have that, we need to be able to tell the Django REST framework that when it is creating this to do, it should set the owner to the person who is currently logged in or who is making that request. So what we can do here is we can override a method called perform create. Okay, so when we say perform create, then we can return serializer dot save, and then we can specify that the owner should be the person who is logged in. So we can say owner equals self dot request dot user. Okay, so since we already have specified that the user should be logged in, then we should be able to get that user and attach them when the Django REST framework is creating this to do. So now that we have our create setup, what we need to do is hook it up in the URLs so that our applications can know about it and people can access it from outside our application. So I'm going to go to the urls.py and set up a URLs patterns. Now we need a path. So then we can say, okay, we're going to now look out for when a user is hitting the create, and then we're going to be rendering our view. So I'm going to come over here and import our views. So from to-dos, views, import. So we need create to do API view. So that's the one we are going to now render when a user hits the create. And then we want to code as view on it. And then we can give it a unique name. So let's say create to do. So let's also import path from Django URLs. So from Django URLs. So now that we have our URL patterns, we need to tell our main routing file about them. So I'm going to come over here, just like we did for the authentication, and do for the same thing for the to-dos too. So it's going to be from to-dos, from APIs to-dos. We're going to be rendering all the routes patterns in the to-dos.urls module, which are going to be everything we have added here. We need to not forget to run our migrations for the to-do, and also make sure our database is synced with the new table we wanted to create. So I'm going to stop the server, and then here I'm going to run Python manage.py, make migrations. And it's going to go ahead and create a to-do migration. And then we need to migrate this so that the table gets created. So here we can run Python manage.py, migrate, and that should go ahead and create all our database tables. So here, now we can run back our application. So I'm going to do run server. Application is back. So I'm going to go to Postman and try it out. So I'm going to come and duplicate this one here. So duplicate it. And let me rename it to create to do. So now we are going to be hitting to-dos /create. And now we are going to be handling the post, because that is the method that create API view handles for us. So now if we come and make this request, hey, by the way, we have our token here set up. So I'm going to come here and say send. And you can see we have an error. Let's see what this is about. We get update sequence elements. Okay, let's see. So we have this error in URLs. This looks something to do with our to-do URLs. So over here, we need to specify a name here and set it to create to-do. So let's try again. I'm going to hit send again. And now you can see we get no such user. That's because this header has been here, I think, for a long time. So we are not able to authenticate this user. So I'm going to come here and log in. And now if we take this token and use it in our create API view, so I'm going to go to our create one. So did we lose it? Let's see. Looks like we did. Create post. And then we are going to say go to authentication and then choose bearer and use this new token. So I'm going to go to the body and I also add some body. So I'll choose row, then I'll choose JSON. So over here, now we can create our JSON object. Let's say we want to have a title of title. Let's have a description, which is this of hello world. Is complete is going to be false by default. So now if we post this, notice that we get this being sent to us and we get a 201 created. So meaning that on our server, we are able to create this resource and the Django Rest Framework is handling that for us under the hood. So the next thing we are going to need to do here to make sure this was created, of course, is to retrieve it. So I'm going to go to the views and also set up a view that can retrieve this. So over here, we can have a class. So I'm going to have a class. It's going to be called to-do list API view. So here we are going to be inheriting from the list API view. So that is the one that implements for us the get methods that are responsible to send back a list of items to the user. So over here, we're going to inherit from list API view. And then that's the one we're going to have here. Make sure I import it and then we inherit from it here. Now what we need to define here, of course, is the serializer class. So here we can have a to-do serializer. Another thing will be the permission classes because we want the user to be logged in. So permission classes, it's going to be is authenticated. All right. Then the other thing that we must specify here is the query set. What kind of objects do we want the Django Rest Framework to send back to the current user? So it's clear to us that we want to be sending only the items that were created by the current user. So what you want to do is normally you would have something like query set equals something like to-dos. Of course, we need to import to-do dot objects dot all, something like this. When you have an authentication system and you want to use the current logged in user to construct which objects are sent back to them, what you want is you want to override the get query set method. So here I'm going to override get query set like this. And what you can do now is instead of using this as a property here, we can just return to do.objects. Then we want to do filter. So when you say filter, I want filter by the owner, who is the current logged in user. Okay, like this. So this is all we need to do. Now let's hook it up to our URLs. So I'm going to come here also and I duplicate this. Let's also import the list to-do list API view. Make sure it's the one we are having here. So here we can have like list and then list to-dos. Okay. And now if we save and come back to our browser, I'm going to now make a get request to to-dos/list. Okay. So you can see that now we get a list of to-dos being sent back. So if we go ahead to post more here, I'm going to go to create again. Then I will put here something different. I will post. We get a 201 created. Let me do it again. And now if we come back to the get, we want to go to the list. We run this. You can start now. We get a list of all the items that we have created. Last time we were able to create our create and list to-dos endpoints. So in this video, I'm going to be showing you how you can shorten it by using a more generic view. So what we did last time is we created two API views. One does the listing, another one does the creation. And in the URLs, we went ahead to set up two different paths for this. But Django Rest Framework actually has another generic view that you can use here to combine the two functionalities. So that is called the list create API view. So we are going to now inherit it. And here where we have create to do API list and also this to do list API view, we are going to create another one. This one is going to be called to-dos API view. Then we are going to, of course, inherit from list create API view. Now we are going to bring in serializer class and then permission classes. It's going to be the same. And when we are creating, so when it's creating, this method also gets called. So we can also override it and also change it and make sure it still adds the owner. And also, we need to also give a get query set such that this view knows that it should only retrieve the items that were created by the current logged in user, like this, and save this. So now that we have this, now we can come over here and comment out this. And we can go to our URLs. And instead of having two URLs, the Django Rest Framework will know how to use one path to handle the two different HTTP methods, the get and also the post. So here, I'm going to comment this and have a new path. So path. So this one is going to be going to, I'm just going to keep it as empty. And then for the view, let's import our view. We call this to-dos API view. Then that's the one we want to have here. Of course, we call as view on it. Then let's pass the name. So name will be, let's say, to-dos, like this. So when we save this, we can come back to our application and just go to to-dos and make a get request. Okay. So when you make a get request here, you see that it is returning for us the same thing that it was doing before. But now when we come and make a post request, let's change some things here and do the post. You can see that still it goes ahead to create our to-do. So that's it. I'm going to go ahead and now clear out all this stuff because we don't need them anymore. So in the views, I'm going to clear out all this. So just instead of using two classes, we can use one and we make it do different things if we inherit from this create. Okay, so that's going to do it for this one. So in the next one, we're going to be handling the view one, delete one, edit one, and update one. Hey guys, welcome back. Last time we were able to refactor our create and list views to use one view that makes it easier to make different HTTP methods or HTTP codes one endpoint. So in this video, we're going to be adding endpoints to edit, delete, and also view one item. So if we go to our views.py, so over here, you guys have seen the pattern already. In generics, there are different views. So we have the retrieve API view that you can use to retrieve only one object. So we can say, okay, give us an object with ID 1, and then it gives it to us. We also have one that can handle the retrieve and destroy, meaning it can handle the view and also the delete. There's one that can handle the view and also the update, but also there's one that can handle all of them. And this is the one we want. So we're going to import retrieve, update, destroy API view. And down here, we're going to set up that class to handle the single to-do instance. So you can say to-do detail API view. So here we're going to inherit from retrieve, update, destroy. So here, one thing we need to tell it is the serializer class, of course. And these other class properties can be used if we need them. So here we can set up the serializer class, the permission classes. We also want to have get query set. So if we wanted to like have a user not see an item they didn't create, and we specify a get query set for the object to be sent back to the user, it's going to first have to match what this query set is returning. And then another thing we need to specify here is the lookup field. So we can say lookup field. So we're going to be using the ID. And by the way, when you come to our list, you can see we are not sending back the ID. So we can send it back in our serializer. So over here, we can come in and say, okay, make sure you also send back the ID. What we are doing here is we are telling Django Rest Framework that before it retrieves or does anything with that to-do item, it should be part of this query set. Okay. So we don't have to really worry about things like permissions if the user is the one who created it. This only will be able to handle that for us. So I'm going to save this and then add this to our URL patterns. So over here, instead of us now having to put all things like delete, update, all that stuff, we can just come over here and specify that whenever we go to our to-do / the ID. So I'm going to have it int ID here. And then now we are going to be sending that to our to-do detail view. So let's rename this here and change this one to to-do and save. Okay, so now if you come back to Postman, I can say get one, and you can see that we get that one. Let's say we say get two. You can see that it's using this ID to retrieve for us that item. Okay, so let's say now we want to update two. We can come over here and make a put request. So let's say we now want to say completed should be true. Actually, I think is completed. Is complete. Yeah. Let's say now we want to say, okay, this one we completed it through like that. Let's send. You can see that here we get a 200, meaning it was completed or the record was saved, and all that stuff is being handled within this view. Okay, so let's check if we can delete one. So I'm gonna go to the list. So just come to the list. I'll do a get for all. Let's say we want to delete this one with the title. So you can see that the ID is 1. So I'm gonna come over here and put a 1, and then I will call it delete. And by the way, you see here how there is a 1 over there. If you put one that doesn't exist, you can see that even this use case is being handled behind the scenes. So really, the Django Rest Framework does a lot of heavy lifting. So if we delete this 1, you can see that now we get a 204, meaning that the object was deleted from the server. So that's good. So this view now is able to handle everything, including having to work with the permissions, having to retrieve one, delete one, and all that stuff just by hooking it in up like this. So that's gonna do it for now. So in the next one, I'm gonna be showing you how to do things like filtering, searching, and maybe paginating these lists. Hey guys, welcome back. So now we have all our CRUD for the to-dos. So in this one, what I want us to do is to look at how we can do filtering on the list that we already have using the same endpoint we have to retrieve all to-dos. So what we want is to be able to come over here and do something like ID equals 2 and be able to make a request to the server that returns us the items that match this filter query. Or we want to be able to say, let me first bring them again. Or we want to be able to say, search for where in the to-do items we have the word mom. So here I'm going to do search equals mom like this. Or this should be search like this. And then you can see we get one that matches mom somewhere returned to us. Also, we want to be able to say, okay, for everything you send us, go ahead and order them by, let's say, the IDs. So this is some customization that we can do client side. And then now you can see that everything is ordered by the ID. If we say order them by completed, we can say is complete. You will see that we get only the ones that are not completed on top, and then the ones that are completed are down. So similarly, we can specify which fields we want to be able to order by just by changing the way we make the request here. Okay, so to get started, I'm going to come here in our project. And the first thing we are going to need to do is to install Django filters. So that's going to be able to give us the Django filter backend. So that provides us different ways that we can filter our data. It gives you a lot of flexibility. You can define things like regular expressions. You might say, I want things to match. You might say, I want it to be full text. So if I make a search, it can match any in these fields that we specify, all those kinds of things. So we are going to be keeping it a little bit simple, but you guys can check in the documentation. I'll probably leave some links in the description so you guys can see exactly what you can do with this. So I'm going to give you an introduction to this, then you guys can pick up from there. So I'm going to stop the server here and install pip install Django filter. So I'm just going to go ahead and install it. So once you install it, then you want to go to your settings.py, and then over here, you want to add Django underscore filters here. So when you have this one set up, then the next thing you're going to need to do, let me first bring up the server. Then you can go in our view, in our list create API view, and then we can specify a filter backends. So we want to do filter backends, and then we can set that one to a list. So first we want to first bring in the Django filter backend because that has a lot of functionality already. So let's import it. So from Django filters dot rest framework imports Django filter backend. So once we have this, then we can go ahead and we specify the filter set fields. So we can come over here and do filter set underscore fields. So now we can set this one to another list. So want to say the user can be able to filter by the ID, also maybe the title, also the is completed. Meta fields is completed. This should be is complete. Yes, so we run this, you can see we get the whole list, but over here we can put this query string, and then we specify that we want to match where the ID is 3. And then you can see we get that one returned for us. So it's using what we specified here in the filter set, and it's just searching by where the ID is 3. So similarly, we can use the title, but if we try to use something that doesn't exist, let's say you see how the description is this. If we came here and did DEC equals this, you can see that it's not matched. But if we come over here and add that we also should be able to match to filter by the description and save and try to make the same request, you can see that now it matches 1. So similarly, we can go ahead and filter by any of these attributes. So here we can have something like is complete equals true. So if we do that, you can see that now it brings this one. But if we say false, it brings the other ones that are all not complete. Okay, so that's how we do that. A lot of the times you're going to want to return items that match a specific search criteria. So let's say maybe a user is doing a search on your website. So over here, you can go ahead and specify a search. Normally you would want to come here and specify for a search, and you want to search for something like sleep. So if we do that, you will notice that what we get is almost everything. And that's because we have not enabled the search filter on our filter backends. So what we want to do is we want to come over here and go to REST framework where we import permissions and also import filters. Okay. So in the filter backends, what we can do is we can go there and add there the search filter. So you can do filters dot search filter like this. So when you specify search filter, then you want to specify the search fields. So I'm going to go ahead and duplicate this and then specify here search fields. So search fields. So when we have that, now we can come here and search for sleep. And you can see that now we match sleep. If we search for something else like test, you can see that it's not matched anywhere. So the other thing you would want to do is to specify the way your items are retrieved. So I'm going to just clear it out so we see what's going on here. Let's say you want to order them in ascending order for the IDs. You would want to come over here and add something like ordering equals maybe ID. So by default, you see we use the ordering order. We use the order for the created at. But if you wanted to say maybe I want 2 to come first or 3 to come second, that kind of thing, you also want to specify the ordering fields here. So I'm going to keep the same thing, but we just change the property name. So this one can be ordering. And also we need to include the ordering backend. So you can say filters.ordering filter. Okay, like this. So now when we save this, we can come over here and say, okay, go ahead and order by the IDs. And then you can see that things now change. You can be able to do a lot of things here. So that's going to do it for this one. I hope it showed you that all the things that you might have been thinking of are possible and they are really easy to implement. If you have any advanced use cases, be sure to look it up on Google. Google is always your friend. and sure, you're going to get some good results. Up to this point, we are able to come over here and make a request to our backend, and we are able to get all these results sent back to us. But whenever we are querying our database, we always want to make sure that we are querying it in the most efficient way. Now, one of the ways that we have to be able to achieve that is to enable pagination on our backend. So pagination will allow us to be able to query a set of results and not retrieve everything at a time. Because if you think of it, if you go to an application like Facebook, you want to be looking at everything at once. And we can implement some pagination techniques that will enable us to show a user a set of content only when they need it or when they are requesting to see it. So now you can see down here we have up to, there are quite many, I believe there are like 70. So let's say we want to be able to fetch a set of these at once. So what you want to do is, I'm going to go to the code here, and what you want to do is you want to go to settings on the REST framework settings, and then you want to enable pagination. So what you can do here is you can set up a default pagination class. So over here, Django provides 3 classes that we can use to paginate our APIs. One of them is the limit offset pagination, another one is the page number pagination, and the third one is the cursor pagination. So to enable the limit offset pagination, and I will talk a little bit more about how it works, is over here, you want to do REST framework dot pagination dot limit offset pagination. So after we define this, we can come over here and specify the limit. So the limit will represent the number of items that are sent back to us. So if we say limit equals 1, we have only 1 result sent back to us. And also, you will notice that we have more metadata sent back to us. So we get to see how many items are there all together. We also get to see if we wanted to fetch the next page, what kind of request we would have to make. So also, we could specify an offset. So the offset allows us to specify a number of items that we would want to omit when we are making the query. So over here, I can come and say, and offset equals, let's say 10. Notice here that the ID that we had retrieved was 41. But if I say offset 10, you'll see that it's going to go ahead and omit 10 and then return for us this. So if we turn this to 20, it's going to now omit 20 and return to us the first item after the offset. So basically that is what that means. And the reason why it is the IDs are decreasing when we increase the offset is because our IDs are based on created data, and we are ordering these items by the latest. So that's why this is going down. But basically the way it works is offset will allow you to specify where the query should start from. So basically here the query starts after 20 items. So this can get quite expensive, and it gets lower as the number of records increases, because the database has to read up to the offset number of rows to know where it should start selecting the data. So basically that is how the limit offset works. So you specify the limit. If I add a 4, you see it returns 4, but then it starts to select those 4 after it ignores the first 20, and then it starts to select the first 4 after the first 20, depending on how you're ordering. Okay, so we can also use page number pagination. So over here I can just, instead of using limit offset pagination, I can use page number pagination. And basically this allows us to specify a page that we would want. Now, whenever you use the page number pagination, you can also specify the per page setting. You can say for every page, which is page size, then you can specify the number of items you want from here. So if you specify 12 and come over here, I'm going to remove these queries for the limit offset and then try to make the same request. You see that we still have a pagination, but now we have a next page given to us. So if we say, we can say page equals 2. So let's make sure it's correct. So if we request the page 3, you see that we have a different set of results. And they give us these pagination links to go to the next and the previous pages, which is cool. Now you might be asking yourself, how do we control the specific number of records that are sent to us and not having to rely here? Because depending on the scenario, let's say one of our users is on the mobile app, from which they have a smaller screen and they don't need to view like 50 items at a time, which you may want to allow on the web application because maybe a browser can process those records faster and the user has a bigger view area. You would want to be able to specify, let's say, the count. So something like the count equals, let's say, 1. Right now, you can see it's not respecting that. But if we want to enable something like that, what we need to do is we need to create a custom pagination class. So I'm going to go to our to-dos over here and then create a custom class. So I'm going to have a module called pagination. You notice here the way this class is implemented, it's rest framework.pagination, page number pagination. So we kind of have to follow the same convention of how we name our things. So over here, we can set up our custom class. So we're gonna have a class custom page number pagination. So over here, we're going to have to inherit from page number pagination. So pagination dot page number pagination. Let's import pagination. So from REST framework, import pagination. So now that we import from here, we can specify a few things. We can have the page size. So we're gonna have page size, let's say 1 here. We can also specify the page size query param, which will allow us to specify how many we want on every page from the clients. So page size query param, then let's set it to count. So we can also specify the maximum page size. So max page size, let's say 5. You want to specify the maximum page size for the reasons like, when the front end controls what the server returns, anyone who is technical enough could be able to control the front end to send a specific query to the back end. But if the back end has a specific restriction on what the front end cannot send, then it's going to be good. And of course, you wouldn't want someone to be forcing your server to be sending a lot of records. So let's set this to 5. And also we can change, you see how we have page? We can change this to something else if you wanted. And you can change that by specifying the page query param. So page query param, let's call it like P and save. So whenever we define a class, now we can come to the individual view we want to use it. So we can come, let's say, like over here, and we specify a pagination class. So let's set it to this. Let's import it. So from do's.pagination, import this. And once we import this and come back over here and try to make the same query, you see that it is now returning 1 because we are specifying the count here. So notice that it is not really giving us the page. If we use the page as P, you'll see that it is gonna still work. So now it's giving us page 3. And yeah, we wanted to request 10, we'll do that. Yeah, so if we specify 10, notice that it's not giving us the 10. It is now using the max. It is now using the max page size to restrict how many we can get. But if we change it to 15 and come back over here and make a request, you can start to get the 10 sent back to us. So now that we have added pagination to our items, let's go ahead and see how we can add unit tests to our API views. Now, adding unit tests to your code is really important because it confirms to you that the code you wrote really works the way you expected it to work. And most importantly, it enables you to spot some unintended behavior, and that helps you catch bugs earlier. So what we're going to do is we're going to add tests to make sure that we can create to-dos and also we can retrieve to-dos. So we're going to go to the test.py file. Now, when you create an app, this file is created for you automatically. So what we want is we want to first import test case from REST framework, because that is the class that enables us to test our API views. So we're going to do REST framework test import. We want to import API test case. Okay, then here let's have our class to test our list and create API views. So test lists create, then we'll head from API test case, make sure we call it to-dos. Over here, let's now create a test that will check that we are able to create a to-do. So over here, I'm going to have test create to-do, it's in self since we are in a class. So every time we inherit from API test case, we get access to a client. So you can think of a client as Postman or car that we can use in our tests. So we can access that by doing self.client. And notice that now we can set cookies on it. We can call post on it. We can call get on it. So what we want here is we want to post to an endpoint. Now our endpoint to create a to-do is called, if we go to our URLs, you will see that it's called to-dos. Here, we want to make a post request to this, and when we are retrieving, we make a get request to this. So here, I'm going to import reverse so we can get the endpoint by its name. So from Django URLs, import reverse. Then here we can now say reverse Then we want to do like this. When we are making a post request, we need to send the data. So on the second parameter, we can specify the data. Now we are going to create a dictionary here for our sample to do. So I'm just going to say sample to do. Then it's going to be a dictionary with the title. I'm going to have hello. Let's have the desk. Let's have tests. So now we have our sample to do that we can use to create. So we can pass it as the second argument here. And then whenever we make a request, it returns for us a response. So we can have response equals this. So at this point, you can imagine what will happen because we are just making a request. We expect it to create or fail. But if you think of it properly, you know that our API requires us to first authenticate a user so it can create. So we really expect this to return a 401 and fail because we have not authenticated. So here we can have something like self.assert equal. Let's check that the status code is a failure and that we didn't authenticate. So we can say response.status code. This should be a 401. So I'm going to import status from REST framework. So from REST framework, import status. So now that we import status, we can go ahead and now say we expect this to be a 401. So that's going to be unauthorized. Okay. So now, if we go ahead and run this test, so I'm going to stop the server and run the test by running python manage.py test. We expect it to fail. Let's make sure it's Python. And we get a failure. So let's check what's going on here. So I'm going to do this. Oh, it's actually a 403, not a 401. So let's make sure this is a 403 forbidden. Okay. Let's try again. Because now this passes, but this doesn't actually create our to-do. So we need a way to authenticate the user before we try to create a to-do. I'm going to modify this test name to make sure that it represents what the test is doing. So I'm going to say test should not create to do with no user, with no authentication, with no, I'm going to say no like this. So basically now we have a test that checks that whenever a user has not logged in, they are not able to create a to do. Now, for us to be able to log in here, whenever we have a client like Postman, we have to go in our auth and we choose bearer token, and then we can add a token. So we need to do something similar in our tests. So I'm going to have a helper here called authenticate user. I'm going to say def authenticate. And what we'll do here is we actually going to be making a request to that register endpoint, to the login endpoint, so that we get the token and we attach it to our client that is in the API test case. So what we're going to do is here, we basically are going to make a request to the register. So self.client.post. So let's reverse. I believe we called it register. We can check. Then we need to send a user. So we need to send the username. Just going to have username in there, the email, then the password, set password. Let's make sure everything is formatted properly. So this is going to go ahead and register a user. Now we need to log in this user. Remember, when we are logging, let's make sure the email is valid so it doesn't fail. So gmail.com. I'm going to make the same request to the login. So I will keep the response to the login in the response because we are going to need to pick the token from the response. So that's going to be self.client post reverse login. Then we need to send the email and password that we just created this user with. So it's going to be email, then password, like this. So we expect this to bring us the token. So whenever you make a request to a server and get back data, that data is in the request, in the response.data. So we expect our token to be in there. So what we want is we want to set this as the authorization to our test client. So how do we do that? So what we want to do is we want to do self.client, then we call credentials. So when you call credentials, you need now to pass in the credentials basically. So we want to pass in the HTTP underscore authorization. Okay. So the value for this, so then we set this to the value. Now we want it to have bearer, since that's the scheme, then space, and then we can now go ahead to add our token. So here we can have the token. So the token is this basically. So it's gonna be this. So let's make sure we need to use double quotes here. All right, show you one and save. So this is going to go ahead and now add our header to our client. So that means that now we can have a test that should create this. We can now have a test that should create a to-do, but first we need to authenticate a client. So we can now test should create to-do like this. So what we want to do first is we want to authenticate a user. So authenticate. Okay. So when we authenticate, now we can do this, but now we expect it to give us a 201. So HTTP 201. So let's go ahead and run these tests again. You can see that now they all pass. So even this, since we authenticate, it passes. If we change this, it should fail because it will not create because the user is not going to be there. And you see it fails. So let's undo that and we run again. And so now we are on. So what you always want to do when you make tests like this, you want to have different scenarios that you're checking for. For example, here, yes, we are checking the status code, but we want to check things like if we're able to send the title, is it the title that the server sent back to us? Also, you want to make sure that if you created through the API view, did the database receive an update? Those kinds of things. So let's first check if that was saved in a DB. So I'm going to have a variable here called previous to do count. Then we'll set that one to to-dos, to-do.objects.all. Let's call count on it. We need to import to do. So from to-dos, modules, import to do. Okay. So we have the previous count. So after we make the request, now we can check if this count increased. Okay, so we can have that assertion too. So we can have self.assert equal. So we're going to make another query. So to do.objects.count. Then we're going to have prev count. We want to check if it was incremented by 1, because when we create, the database should update. So let's rerun back. This should pass. It actually fails. The import, this should be to-dos. Okay, let's rerun. And you can see that now they pass. So let's also go ahead and add an assertion that the title we sent and the description we sent were the ones that were sent back to the client. So we can do self.assert equal resist.data. So it's going to be response data. Then we want to check for the title because we expect it. Then we want to make sure that it is equal to hello. So make sure you have hello in there. Then let's check for the desk. Make sure it is tests. Okay. You can also add any kind of assertion you want. Just be sure that you've tested all the cases that you would want your API to always respond to. And now if we run this, you can see that things are still fine. So since we are testing both creation and also the retrieving, let's go ahead and also add a test that can retrieve all items. So over here, we can have a test retrieves all to-dos. So over here, what we want is, of course, to make a request, and we can use the client. So I'm going to copy the same thing here and bring it down here. And now we have to make the get request. So we want to do get here. Get doesn't take the body, so we can remove the second parameter. And we also want to first authenticate, so we can as well first authenticate. So self.authenticate. Otherwise, we will get an error. So now that we have the response, we can check that the response return is 200, because even when the API hasn't had any creations of to-dos, it should still send us 200 and it should still send us the empty list. So let's first add those assertions. So self.assert, let's check response, status code should be 200. So status 200, okay. Let's also make sure that we have the results. So we can have self.assert is instance. So we want response.data results, and it should be an instance of a list. Make sure we tap this one in. So let's run back again. They should be 11 and they should all pass. And you can see that now they are all passing. So that's good. If we want to check that whenever we create, we get the pagination links, we can also add that. So I'm gonna go here and copy this. And obviously you could write this one better, but I'm just showing you basically what testing will consist of. So let's make another post request. And at this point, when we make a get request, we should expect it to have pagination links like the next or the current count. So let's make another request. So I'm going to say the response here. And now we will expect it to have the count. So I'm going to have his instance here, and the count should be an integer, and of course it should equal 1. So let's have count there. The type should be int. Okay. Let's also check that it's 1. So we can now check assert equal count should be 1 here. Okay, so let's do this over here to use the new one. So res equals that. That's the only one I check here. Make sure that it got updated when we created, and when we make another request, we have the update. So let's run back again, and you can see that they pass. But you can go ahead and check anything you want to check here. This is just an example of how to approach it. Last time we were able to test if we can create a to-do, also if we can retrieve all to-dos. We also went ahead to test that a user should not be able to get to-dos when they are not authenticated. So in this one, we are going to go ahead and add tests for the other API views we have. So we want to be able to test that we can view a to-do, we can be able to edit it, we can also be able to delete it. So what we are doing here is we basically create a class that inherits from API test case, and then we go ahead to test the different views. So in here, we are testing that we should view all, and also that we should create one. So basically we tested this here, right? So let's go ahead and test this. So over here, I'm just going to create a new class. So I'm just have here a new class. So I'm going to call it test to do. So let's check the name of the view. So it's going to be to do detail view. So we have to inherit from API test case because yes, we are testing APIs. So here, let's make sure this is formatted properly. So here we need to have 3 test functions. So we're going to have tests retrieves one, takes himself. We're also going to have the other 2 to edit one and also to delete one. So I'm just going to copy this and have a duplicate it a bit, indent it, make sure it's good. This should be updates, views, updates, then deletes. So if we run back our tests, we should get more tests added here. Now you see we have 14, but these are passing because we just have pass. I guess it just looked at us saying pass and then it passed. No guys, I'm just kidding. But let's go ahead and add something meaningful here. So to be able to test that we can retrieve a to-do, we need to first have one to test with. So meaning we are going to need to have a setup that creates the to-do that we are later going to try to view. So if we come over here and try to right here where we created to do and try to find this, you notice as we have already written this in many times and we don't want to be repeating things that are the same. So what I'm going to do is I'm going to try to find this everywhere we're using it, everywhere, and then I'm going to cut it out. Then I'm going to replace it with a function called create to do. So I'm just going to call it self.create to do. So then let's go ahead and create this. Now we have not cleaned out the sample to do. We will do that. So I'm going to come over here and also have it. So def create to do. So what we'll have is basically a function that created to do. Now let's first find the sample to do and bring it in. So I'm going to find everything and just cut them out. Make sure it's not repeated. Then we come over here and declare it. So this is going to return the response. Now we need to be returning that response because I believe somewhere where we were using it. So over here, we can return response. So if we try to find where we're using create to do, it's that here, whenever we say create to do, it's going to return us that response and we can work with it like this. So if you don't need to work with the response, no worries, we can just create like normal. Let's make sure it is still passing. And it is still passing even when we refactor it out, which is good. Now, guys, that leaves us in another set of problem because right here we are in another set of class and we can't usually go ahead and say self.create to do like we did in the other classes. No, what I'm going to do is I'm going to create a class up here that's going to help us do the setup. So over here, I'm going to have a class. So I'm going to call it to do API test case. I'm actually going to call it to do's because we're going to use it in many places. And in this one, we can now go ahead and handle the create to do and things like authenticate. So I'm going to copy authenticate and also create to do. Take it from this class over here and bring it to this one. So since this one already inherits from API test case, so it goes ahead to handle things like creating a to-do and authenticating a user. And we would want to be using this in all the other classes that we might have to test. So what we'll do is we are going to make this one, instead of inheriting from API test case, to inherit from to-do API test case. And that's going to make sure that we can still access the correct to-do and also things like authenticate. Okay. So now if we run back the tests, it should still work fine. And you see that they are fine. And now this way, we can go, and now this way, we can go in our new test class and inherit from to do test case also, and be able to do things like authenticating a user. We can do self.authenticate. And also we do things like create to do and create the to do to test with. Okay, you see that? So it's going to return us the response. Okay. So at this point, we can go ahead and create a to do like this. So now when we create a to do, we can now try to make a call to go ahead and fetch it from the view. We can do res equals self. Since we inherit from this also inherits from API test case, so we have access to the client. So we can do client. We want to do a get. Now, remember we use reverse to reverse the name so we can get the details of the URL. So this one is going to be called to do. Remember, so for us to be able to access this URL, we have to do something like to do /1 to do. I guess it's to do's, yeah, to do's, yeah, to do's /2. So now we need a way to pass a dynamic argument in this reverse so that the view can handle it correctly. Now, what you can do when you pass reverse, you can put a comma after you specify your name, and then you specify keyword arguments. So you can say quags equals, we need the ID, and then we can pass in the ID. Now, whenever we create a to-do, it's going to give us that ID in the response. So over here, you can say response.data, then the ID is what we are trying to view. So we expect this one to, of course, be there so we can have an assertion to self.assert. So we want to have, so let's first check the status code, should be 200. So it's going to be status.200, okay. Let's also check that the one that is sent to us is the one in the database. So I'm going to come over here and try to query the one in the DB. So I'm going to do, so to do equals, so it's going to be, I'm going to try to find it by the ID that gets sent from the view. So now we can do to do dot objects get. So we get by ID, it's going to be, so whenever we create one, it sends us the ID of what was saved. So whenever we now make a request to the view like this, we want to make sure that the one that the view sent to us is the one that's in the DB. That way, we can verify that our DB is really persisting things properly and our view is working properly. So here we can have self.assert equal, I guess it's this. So we want to assert that to do dot title equals the title that is in the response. So we can do res.data title like this. So now we can run back our test and you can see that it is still working. All these assertions are still working good. So let's go ahead and test. Let's go ahead and test update one. It should be really simple. So of course there, what we want to do is we want to go ahead and authenticate the user, create a to-do, try to edit that to-do from the view by making a patch request, and then make sure that we update it in the DB and we get a successful response. So how do we do that? Definitely we want to authenticate, want to create, then we want to go ahead and try to edit it. So here we can have, I'm going to have another, in fact, let me remove this response, the response assignment. Then I'm going to have a response. I'm going to set it to self client. Let's make a patch request. So when we do patch, we want to specify the URL. Now, since this is a dynamic one, we want to use a reverse and pass the keyword argument for the ID. So we want to patch this. Now, the next parameter you pass here is the new body. So we want to make sure that here, oh, we need the access to the ID. So let's have it because that. Then let's have this as res. Make sure we don't confuse. So we need to pass a new one. So here, I'm just going to have a title. So I'm going to change the title from what was there to something like new one. Okay. I'm also going to go ahead and change is complete. So by the way, I'm also going to go ahead and change is complete. So is complete. Set that one to true. Okay. So now that we change this, we need to now make sure that the DB really updated and the view responded successfully. So let's first have the assertion for the view responding successfully. So assert equal. So it's gonna be rest.status code. We want to make sure that that is a 200. So over here, whenever we make a request to create the to-do, we have the ID of what was created inside the response. And we know that whenever we create at first, the default value for the is complete is going to be false. So now that we change it to true, we can go ahead and assert that it really changed to true. So I'm gonna go here and have another assertion. So we're gonna do self.assert. So over here we can have a to-do objects get. So we wanna get by the ID. Then we're gonna use response data, the ID. We want to make sure that the is complete value of this is true. So we can come here and set this one to true, like this. And by the way, I want to move this one away, make it updated to do. So let's declare it updated to do. Okay, so we expect it to now be true because we have gone ahead to edit it, even when it was false at the start. We can also check the title because we changed it here. It should be new one. So we can say updated to do dot title should be new one. Right here, when we are querying, we need to say ID. We want to get for the ID of the to-do we created here. So that's going to be response data ID. So let's try again. And now you can see that they pass. If we go ahead and change this, let's say we change this one to 1 and run back again. You see that now it fails because it updated correctly. So this way, if someone changes our code in one way or the other and something they never intended, the test will catch it and they will have to come back and really check if they really meant to make the change that they had made. If that's the case, then of course they can go ahead and modify the test to perform okay, and your code review should be able to check that and make sure okay, this was the intended behavior. So that's good. Let's go ahead and add the one to test that we can delete an item. Basically, on this one, we want to be able to authenticate the user, create a to-do, check that in the database we had a specific number of items, then go ahead and delete a to-do and check that the number of items reduced. All right. So that's how you would think about it. So let's go ahead and implement it. So we want to first authenticate. So authenticate, then we create self.create. Now let's check how many are there. So I'm gonna say prev db count. So then that's gonna be to do objects all count. So this is gonna represent how many are there in the db. Let's first make an assertion to make sure that they are greater than 0 because this should create 1. So we can have a self.assert. In fact, you can say assert greater and make sure that the prev db count is greater than 0. Okay. Can even make sure that it's 1. So assert equal 1. And now let's make a request to delete. So you can say response equals self client. We want to make a delete request. The URL is dynamic. So you know how we do that. We pass the reverse with the quads. So I'm gonna copy this, make sure we are passing that. And we need the response, of course. So I'm going to save the response we get when we create it in res. Then we can now use that. That's the one we are going to try to delete. So every time we delete successfully, we expect this one to return a true form. So we can have an assertion for that. So self.assert equal response status code. That's going to be status dot a true form. That's what our server returns. So we also want to make sure that at this point in time, the items in the DB reduced. So we're going to make a new query and assert that the items reduced. So over here we can have an assertion. So self.assert. In fact, we can say assert equal. So we want to make sure that if we call this, it's going to return 0 because we deleted it from the view. Okay, so let's run the tests again. You can see that now they are still all passing, and yeah, so this means that our view is working and it's correctly interacting with the DB. So that's gonna do it for this one. If you enjoyed it, give it a thumbs up. Don't forget to subscribe. I will talk to you in the next one. Hey guys, welcome back. So in this video, we're going to go ahead and see how we can document our Django Rest Framework API such that when we are done working on our backend, we can avail that to people and other people can understand how to interact with our API. In the real scenario, whenever you work on a REST API, you want to provide a documentation that can be used by other developers to know how they can interact with the API you built. For example, if you had someone that was making a mobile app for the API we've been making, then they don't really need to know about how that API was made. For them, they just need to know, how can I make a request to the backend server? How can I make a request to basically the API? So for us to be able to provide that documentation, we have certain tools that we can use, but in our case, we are going to be using Swagger. So what Swagger is going to be doing is, we are basically going to describe how our application is structured, and then it should be able to generate this documentation automatically for us. So let's go ahead and get started. Now we're going to be using this drf yasig module. So we're going to need to install it. So I'm going to come over here and copy this command to install it. And in our app, then we can do pip install drf yasig. Now make sure you're in your virtual environment, otherwise it will not work. The next thing you're going to need to do is add drf yasig to our installed apps. Another thing you may notice here is we are going to need to make sure we have the static files app in our installed apps. That's because drf yasig, of course, will give us a UI that uses HTML and CSS. And this is an app that Django provides that can enable serving those static files like HTML and CSS. So we're going to make sure that we also have that. So in our settings.py, so I'm going to go to settings.py. Now, if we go to our installed apps, first we want to add the module just installed. Also, make sure you have this. Let's come back to the documentation. So basically what we need to do is describe some metadata about our API. So I'm going to copy this and go to our urls.py. Let's also first get it here, then we can take a look at it. So on the schema view, we can first describe what our API is, who is it for. So I'm going to change this one to do API, but feel free to change this to your liking, or depending on the application you're working on. Of course, these are going to be different. So also, we need to define the URL from which it's going to be served on. So I'm going to get these URLs here, and we're going to talk about how they differ in a minute. So I'm going to bring them down here. Then I'm going to change URL to path, and wherever we have this, I'm going to change it to use just the string. And also I'm going to remove these ampersands over here. We don't need them. So if we go back to our website, now you can see we have these URLs. So I'm going to go to /swagger like this. And the reason why we're getting forbidden is because we configured our application here in the settings. If I could show you. So in our REST framework, we had configured our application to use JWT authentication. And that's why this is defaulting to forbidden. So what we want is, if you go here in the docs, you can see that we can also be able to supply the authentication classes. So I'm going to copy that authentication classes, and here in the URLs, you can go ahead and add authentication classes. And then we set that to empty. Okay, so now if we come back to our /swagger, you can see that we have our documentation that we can give off to anyone, and they can see how they can be able to interact with our API. So on here, you can be able to come and you try it out, and yeah, you get the server to respond, which is pretty cool. So that's how you enable Swagger. Now you can also use the redoc version. So I'm going to do redoc, and you can see that it also is the same, but it is documented differently. Now that's going to be it. You may find some use cases where the initial setup may not work for you. So every time something doesn't really work for you when setting up documentation, make sure you come over here and you read up with the configuration. So one URL that I would like to show you is this one for JSON or YAML format. So this allows you to export basically our documentation into JSON, and that can be exported or imported in other documentation tools. So here I'm going to change this from Swagger to swagger.json. Okay, and then if we go to our application now, if we come here in our app and we go to /swagger.json, you can start to get a JSON file downloaded here. So I'm going to open it up, and this contains the specification for our API. So to bring out our documentation into our Postman, what we want is we want to go to File, then we want to click on Import. So over here we can drag and drop our file here, but also we can use a link. So here in the link we can bring in our JSON file, which we can find at our site /swagger.json, like you saw. So swagger.json. If you click continue here, you can see that it gets it. It can detect the format it's in, and it's going to be imported in as a documentation. Then I'm going to click import. So that's going to go ahead and create a correction. If you don't know what a correction is, it is just a way for Postman to organize your API requests. So I'm going to close here, and now over here you can see that it's going to go ahead and refresh, and in our APIs we have this to do API. So I can click on it, and down here I can click on our documentation, and you can go ahead and explore more here. So as you can see, this is what we had in the Swagger UI, and this is just another way that you can use to basically look at how the API is documented. So we also get a correction created, which is now here, and we can go ahead and test out all our endpoints without having to really copy one by one. So that's gonna do it for this video. If you guys have any questions regarding this, please be sure to leave them in the comments. I will check them out. Thanks for watching, and have a good day. So in this video, we're going to be looking at how we can get our API off our computer and put it to a live server. So one way that we can deploy our Python applications, in this case our Django applications, is to use a service called Heroku. Now Heroku allows us to create an application, and then we can upload our code to Heroku by using Git, and then Heroku takes care of serving our application, and they give us more insights on what's happening in our applications. Now Heroku is free for starters, so by default you can get your application on Heroku without actually paying money. But if your application is going to scale and demand more resources, then you're going to have to upgrade your Heroku plan. So be sure to log in to Heroku, and over here you will find apps. If it's your first time you want to find any app, so go ahead and click create app. So I'm going to click create app. Okay, so it's available. Now you can go ahead and create the app. You'll see an option like add to pipeline. So this is the way that Heroku allows you to manage different environments. So if you want a specific version of your deployment, let's say you want specific changes to be in staging, other changes to be in development, other changes to be in production, you can do that through pipelines, but we won't be getting into that right now. So let's go ahead and create our app. So when this is done, then it's going to go ahead and create it. Now you would see that there are different ways we can connect our code to Heroku. One is through the Heroku CLI, one is through the one is through GitHub. So the one I prefer most here is GitHub, and that's because with Heroku you can set it up in a way that every time you make new pushes to GitHub, Heroku goes ahead to automatically deploy your new changes. So that's cool. Now we're going to select GitHub. That means we're going to need to have a GitHub project. So I'm going to come over here to my GitHub and also create a project. So github.com. Then you want to go to new. So over here, then we can create a new project. I'm going to give it the same name, just so we have a consistent app. It's the same app anyway. So you want to go ahead and create the repository. So once you create this, now you can come to Heroku, and down here to connect, you can search for your repository. I'm going to click search, and you can see that they have discovered it. So you want to click connect. So once you have it connected, we're unable to access the connected repository. Either it's empty, which is true. Anyway, it's now connected. So what we want to do is we push code to it. So I'm going to copy the default commands that they give us here to be able to push to it. And then on my local computer, I can paste these commands down here, and then it's going to make a push. The initial push is going to be pushing only the readme file and not any of the Django code. And now if I refresh here, we should have the readme at least. Now you can see we have the readme. So to push the other piece of code, there are some things you're going to first need to do first. One is we don't want to be pushing our secret key to GitHub or anywhere else. So I'm going to move that, and then I'm going to create an environment file. So here I'm going to create a .m file. Then I'm going to have a secret key. So we can define environment variables by using export. So you can do export secret, and then we can set it to a value. So I'm going to remove this, just make sure it's we need to update our environment to know about this file. So we can do that by doing source.env. So now that we have that, instead of us using this key here, then we can go ahead and use the one in the environment. So I'm going to import OS here. So import OS, and then here we do environ get, then the key. So the key here is going to be secret key. That's the one we want to have here. And once we are done with that, there are some other considerations we need to do, like turn this to false if we are in production, which we should do here. Another thing we need to do here is specify allowed hosts. Now, allowed hosts basically describe which domains should serve your application. So if you're going to have your API be served on myapi.com, that's what you want to have here. So for now, what I'm going to do is just put a wildcard to enable it to be served anywhere. The other things we need to set up is a way to serve our static assets. Now, Django doesn't serve static assets by default. They give us this static files app, and this doesn't serve our static assets in production. So they leave that one to us to manage it. Now, there are several ways you can manage it. You can integrate a service like S3 to manage your static assets. So we have other solutions like white noise that allow you to serve your static files directly from your Django application. So that's what we're going to be using. You can come over here on white noise and you read about why people are motivated to even make this project. So I'm going to come over here and install that, because we want our documentation to be shown even when we deploy to Heroku. So once we have that, we need to add a middleware for it. So I'm going to copy this line here, then we take that to our middleware. So on the second line, we will have this line added. So once we are done with that, if we wanted to set up caching for files, we would go ahead and add this. But right now our application is really simple. And now to configure Heroku to deploy our Django applications, we are going to be using this module called Django Heroku. So to make this work, what we need to do is we need to import it here in our settings. So anywhere in here, and then we need to run Django Heroku settings. So that's gonna tell Heroku to know how to handle things like static assets, to know how to set up your databases and all that stuff. So I'm gonna come over here, and this is gonna enable Heroku to pick up these settings that we defined here. So it's gonna know how to work with the databases, how to work with static assets. So once we have this, then we can go ahead. By the way, we need to install Django Heroku. We didn't. So let me just come over here, run this installation, because it's gonna be needed for it to work. So we also are going to use a server that is going to serve our application. So by default, whenever we are running locally, we have a development server that Django sets up, but that's not really efficient. It can only do as good as helping us to develop. So we're going to install G-Unicorn. So over here, I'm going to do pip install G-Unicorn. So when it's done installing, then we want to define a proc file. Now a proc file is a special file that Heroku uses to know how to do specific things when it is deploying our application. So over here, I'm going to create a file called proc file. So you can see that it has the Heroku badge in there. So over here, I'm going to bring in this piece of code now. Now what this basically means is whenever Heroku is going to serve our application, we want it to run this command. So we want it to run G-Unicorn, and then we give it a path to our WSGI file. So this, you can think of this as an entry point to our Django application, and that's a file that is here. So if you take a look at our projects, you can see we have to-do lists API, then we have WSGI. So this is the file we want to point it to. So over here, we also tell Heroku to run our migrations every time it is deploying, also to collect static every time it is releasing our app. Okay, so now that we finished setting up our proc file, we need a way to have our project dependencies in one place such that Heroku can know which dependencies it needs to install before it can run our application. So over here, if we did a pip list, this should be able to show us all the dependencies we are using in our project. Now these are the ones we want to tell Heroku about. Now Heroku is going to be looking for a file called requirements.txt. So let's go ahead and create that file. Now we can create it using pip by running pip freeze. Then we give it a name, requirements.txt. And now you can see we have a requirement.txt file created, and it has all our dependencies. So now that we have this, we can commit these ones to Git. So git add everything, git commit -m for the message. Then we can say added all files. Then I'm gonna push this. So I'm gonna do git push. So that's gonna go ahead and update our GitHub. So in Heroku, if we come back to Heroku, and we go to our settings, in the settings we can be able to set up our environment variables. Remember how we moved our secret key to our .env? So we can now copy over our environment variables. So over here, we can bring this one in. And also we can set up a value for it. So I'm going to copy this string here and also make sure it is here. So when Heroku is running our application, it's going to look for this environment variable, and it's going to use that instead of basically leaving it in the source code. So now if we go back to our deploy section, I'm going to refresh this page just so we get rid of this error. So down here, you can see that it's connected. So I'm going to go over here and trigger a deployment to the main branch. So I'm going to click deploy branch. So you can see that we have an error. That's because it's looking for this module called psychopg2. I was hoping we installed it, but it looks like we didn't. So if we go to our requirements.txt over here and try to search for it, you can see that it's not there. Now what I'm going to do is install. So psychopg2 is a connector for Python and Postgres. Now that's what it's looking for. That's because Heroku by default gives you a Postgres database that you can use for the application. So it needs this to be available. Now what I'm going to do here is I'm going to install psychopg2 binary. So this does the same thing, but this is now the recommended way of installing that library. So once the installation is done, then we can go ahead and update our requirements file. So we can just do that by pip freeze again. So that's going to go ahead and update it. So now that we are done here, then we can go ahead and push again. So git add everything, git commit -m, you can say add psychopg2. We can come back to Heroku and retry the deploy. So I'm gonna click deploy branch again. You can see that it runs our migrations just like we instructed it in the release phase. And when done, you can see that the deployment, the app was successfully deployed. And when we click on view, it's gonna go ahead and open in a new tab. And you can see that we have our application here. Notice that we don't have our documentation. That's because it is on /swagger. So if we do /swagger, and now you can see that we have our API fully documented, and we can share this URL to anyone in the world. So that's it. Those are the basics of how you can get your application up on Heroku. So if you have any questions, feel free to leave them in the comment section. I will sure review them, and I can get back to you if I have an answer for you. So thanks guys for watching. I will talk to you in the next series.